Welcome to Web Security. And first of all, I want to congratulate you, welcome you to the class. I think we're gonna have a lot of fun. We are gonna, at least I'm gonna try to make it as fun as I can. So let's get started. The number one thing I want to go over before we get started, okay? And I think let's just get this out of the way so we can just focus on hacking and having fun. Um, it's a little bit of my philosophy that you're gonna see as we go through the course, as well as some caveats that I think you should keep in mind as we go through this. The first thing I'm gonna do, and I'm going to impress upon you, is this information that you're gonna be learning in this course can be used for wrong and for good. Okay. One of the reasons why I want to teach this course, besides the fact that a lot of people have been asking for something like this from myself, is that as the web becomes more and more prevalent in each of our lives because of the devices we have, mobile, and all these things that are now coming in line with IoT and all that, I think it's more important than ever that we understand at least a little bit about security, even if you're not, trying to go into the field and become a penetration tester or anything like that, right? So even if you're not a pen tester, I think it's really important to understand the web. I think it's really important to understand security because you're dealing with these systems, and if you're not thinking about security, then you can understand that that's a risk. But beyond that, I do want to tell you that you are responsible for your own actions, okay? So I'm not going to tell you what you should or should not do with this information. I'm going to assume that you're going to do good things with it, okay? So with that being said, I'm going to push forward, and then we're going to just get right started in the course. Now, what are some of my philosophies about the web and about web security and bringing those two things together? I think more and more, and I think we saw a lot of it this year and maybe in the previous years because of Facebook and whatever. There's been a lot of data breaches, at least according to the news. Honestly, you can believe what you want, but here's the thing: the web, when you think about it, in the past 20 years, we have created a technology that has united more people than ever. Right? We have created technology that we can share information like never before, and this is information that no government and crosses, this goes across borders. This really gets to the heart of the matter of what it means to have a free society, and I think free information. So I think the first thing we need to remember about the web is what the web is supposed to be for. And the web is a place where the whole world can come and connect together, okay? And never before have we been able to do this, okay? So I think we should be very careful in the next few years. And this is something for you to think about. This is more on philosophy side of things, before we get right into the meat and potatoes of the course. But the web really is a remarkable thing that we have, and I think we should really be careful and take care of it, okay? Because it's going to be important in the coming years. And again, when you really think about it, everything that we've been able to share, you can pretty much go online and find any information that you're looking for, whether it's a video on how to create a house or how to tie a tie, or a grandparent seeing pictures of their grandchildren. So the web is really an amazing place. I don't know how else to say it, but I think we should really be careful. And I think to give that control over to any government agency or any other single entity without really thinking about what we're giving away, which is pretty much our right to communicate, I think that's a huge mistake, okay? So with that being said, let's get started into web security, and let's have some fun, okay? So the first thing, let's go over what's going to be included in the course, what are we going to cover, and what are some of the things that I want to get across to you in this course. The first thing is the attacker mindset, and this really goes to the matter of if most of us are web developers, and we're pretty much working with systems, or we're having to use code base that's going to be published on the web. And the truth is that if you're not thinking about web security when you're writing the system, then the system is probably vulnerable, right? So over here in this class, we're going to be going over some attacks, okay? And then we're also going to be going over some of the defenses for these attacks, because in order to defend against the attacks, we also have to talk about them, okay? So we're going to be, again, going over the attacks, and then we're going to be going over how to defend against them. We're also going to be going over what are the mindset that attackers are thinking about, and also what are the skills that they have and the skills that you need to have in order to defend against these attacks, okay? Now, why is security hard, especially on the web? Well, the first thing is there's a lot of buggy code out there, right? There's a lot of code that has been published over the years, and if you think about how the web was constructed, which is at the beginning it was just for academics, and it was for academics to be sharing code in universities. It was for to be sharing links, documents. But over the years, we have really created something much bigger, and the web has evolved into something where we have videos, we have created full-fledged applications on top of this protocol, which is HTTP, and that wasn't really what it was meant for when it was created, right? So this has created some interesting engineering problems that some people have exploited in order to to take advantage of the system. Now, another reason why security is hard, especially in the web, is that social engineering is very effective. And this is true for any type of security, right? So the fact that there's so much information, okay, in one place, the fact that it has become such a large vector, meaning that right now there are more websites by a mile than there are applications, right? So because there's all this information on the web, and at the end of the day, there's people behind this information. Pretty much, it makes it vulnerable because social engineering and the fact that you can convince people or get information from people and then use that information on the web to gather more information, then that becomes kind of a self-fulfilling, like a cycle that that's pretty tough to guard against at every scenario. And the most obvious thing also is that there's a lot of money to be made, right? Information is power. And just the fact that, like I said, the web has pretty much the biggest repository of human knowledge in the world makes it kind of a huge target for exploiting, and there's a lot of money to be made. So because of this, security is really, really hard, especially when it comes to the web, where you don't have control over the full system, right? Now let's think about some of the vulnerabilities, right? When you think about the web, what are some of the vulnerabilities that you know of? Okay, there's ransomware. Okay, and we've seen a lot of this when it comes to cryptocurrency or systems being locked down, whole websites, and having to ask money in order to release a database or whatever. But ransomware, okay, ransomware, it's an attack surface that people have exploited, keyloggers, right? So if you can deploy some type of code on someone else's machine, you can maybe install a keylogger and then figure out username, passwords to their accounts, bank accounts, whatever it is. But keylogger is something else that we've seen on the web. Crypto mining, okay, and we've seen some of this stuff. I think it's not as big a deal as people make it seem, but I've seen attacks where people are installing just code that mines cryptocurrency, and that's an attack surface, I guess. DDoS, so denial of service. On the web, like I said, someone can lock down your computer or your website and deny you the service of it. If they have your password, if they have your information, then you're pretty much at the mercy of the attacker at that point. Also, there's spam. So someone can spam your service, someone can spam your server, and pretty much do whatever they want to do. And with spam, there's a lot of attacks that can come from that point of view. There's also blackmail, so camera hijacking, because the web over the years, we've tried to evolve it and make it a full-fledged platform. Developers have been asking and have been wanting to create better applications that are published on the web, and we don't have to, so that way we don't have to go through app development kind of processes, or be subjective to any platform. And like I said, the web is a place where we can all do this. So developers over time have been asking for more and more low-level APIs. So if you've worked with maybe WebGL or any of the Canvas APIs, or maybe the Camera API, or like WebRTC, all these things that or even the file system, over time these things have become more and more useful, okay, for building applications. And we have been wanting to put these applications online. So these APIs have become available, and through the browser, we've been able to use it as developers. But then this also opens up a lot of attacks that before, again, this is not something that the web was made for. So it creates kind of a vulnerability on that end. Also, there's a lot of potential for data theft. I don't know if you've heard where you are, but some banks have been some data breaches have happened in banks, and maybe some more personal data for political reasons, or anything along those lines can happen on the web or any place that there's a lot of information. And again, as the web becomes more and more the place where applications are hosted, then this is, I think, just going to keep on happening. And for that reason, that's more of a reason for us to learn a little bit about security and how we can defend against some of these attacks. So let's just go over some of the stats. And again, I just want to, we're just going over some of the overview stuff so we can get kind of an idea and get on the same page about what we're going to be learning about. But here's just some stats of number of records exposed. And these are just stats I pulled as of the year of 2018. And over the years, you can see that it's been growing, So, more and more attacks are happening. But again, also the records exposed are less, or depending on, you can see a spike over here in 2016, 2017. But again, the main idea is that if we're not guarding against these things, then they're bound to happen, okay? And as you'll see in the class, there's a lot of vulnerabilities still. And as we tried to make the web backwards compatible, right? So there's still people that are using Internet Explorer 6, 5, whatever. And not everybody has computers that are up to date, right? Or as devices that are connected online in all parts of the world where everybody doesn't know how to use them. Then there's a lot of vulnerabilities on that end as well, right? So there is this tension between us wanting to put the information on the web so it's accessible, but at the same time secure the information so that only the right people, right, have access to it. And as we put medical records online, or if we put more of our personal information online, then then this tension continues, and it becomes more of an attack vector as time goes on. Okay, so what is web security? Okay, let's think about this for a minute. Okay. So if you get nothing else from this course, let's think about, this is probably the most important thing to understand. The same origin policy. The thing that the browser, and specifically the browser, when you open up a browser and you enter, the internet, for lack of a better term, the same origin policy. And what the browser is trying to do is trying to isolate sites from each other while running in the same browser, right? So if you know about processes and tasks, okay, and about how computers work, the browser is just a process, okay? And within this process, there is a lot of tasks, okay? And the task is the thing that allows us to navigate to different URLs, different websites, get data from the websites, load data, images, videos, text, whatever. And the thing is, when you open different tabs, or as you have different things open, for example, let's say you have your bank account open, and at the same time you have your Facebook account open, and maybe Spotify or Netflix or whatever else, you can see how these apps are operating in the same browser window, but they should not have access to each other's information. Okay, now this is where attacks can happen, and because again, you're dealing with different secure access levels, right? So one service, for example, let's say Facebook, you can upload pictures to Facebook. So Facebook, or music, or you can even write text or videos, and this needs access to your computer files. Okay, so on one end you have maybe services that need access to your file system. On the other end, you have services that have information about things you watch. On the other end, you have information about things you listen, and all this information, again, is different access levels to your own computer resources, as well as to your own personal resources that you have on your computer. So it's not just the processing resources that your computer has, but also the resources that you have put in your computer, right? So if someone gets access, for example, and can install a script on your computer, and through that script they can execute some type of code, which is done through JavaScript, then at that point, you can find yourself in a position where an attacker has complete access to your system. Okay, and again, if you're a web developer and you're creating websites and applications online, then this is something that you need to be aware of. Okay, but that's what essentially web security, and that's what we're going to be really talking about in this class. How do we create processes that are isolated and at the same time can protect the data integrity within their own processes? Okay, and that's probably the most important thing to understand out of the class. So let's continue here. So there are there's a few types of securities, right? So there's server app security. So the idea is that attackers can run arbitrary HTTP clients, and they can send anything to a server. So if we have the server client model, right, where a client can ask for resources from a server, right, and let's say you go into Amazon or Netflix or Facebook, right, when you enter your login credentials, then those websites actually send back from the server something that's personalized to you and your own history on the website. And your history will be different than someone else's history. But the fact of the matter is that, any client can send to the server. Let's say you upload a picture, okay? And then let's say someone else visits your Facebook account. That picture is going to load for them as well. So now the whole thing, because we're sharing this information, is someone, has some malicious code on that on that resource, and that resource gets loaded onto other computers, then those computers can be infected as well. Okay, so again, because of this, you want to be careful, and again, that's what makes it even more of a security risk on the web, because on the web there's really nothing stopping us from accessing pretty much any resource on the web. And since there is so much, anything can there's a lot of potential for something wrong to happen. Okay, there's also client app security. So prevent users from being attacked while using web apps locally. So as applications become more powerful and as computers become more powerful, we are seeing now that you can store a whole database on the browser, or you can execute some pretty powerful, even machine learning algorithms on the client side. Okay, so as computers become more powerful and as we start building more powerful applications, and these applications can live on the client fully and operate on the client fully, then these applications have access to client resources. Okay, and if they can then go ahead and communicate online and pass this information around, then again, this opens it up to a lot of security risk potential. And also, we have to think, how do we protect the user from social engineering? So because we don't have control of what the user might input, what the user might decide to load, and the users might actually have no malicious intent when they're maybe copying some code or a picture and then just pasting it on their website. If they got that picture from a website that's been infected, then that picture can infect many other websites without even the user knowing this. And again, if you are on a service that you're providing this type of functionality for your users, then you need to know these things. Okay, and also we're going to be talking about how ads and pretty much things that can follow you online and have this omnipresence, kind of as you visit more and more websites, and we want to deliver a more customized, okay, and a more tailored experience to each user. This also means that we need to track behavior across not just different websites, but across devices. So how do we balance that tension between being able to deliver a tailored experience while at the same time protecting the user privacy? Okay, and these are the things that these are still some of the stuff that's being worked on the web. But you can see how over time, these things have to be resolved somehow. You can, opt in to say, I don't want any tracking. I don't even want JavaScript to execute in my browser. But then you lose some of that functionality. And again, that's completely up to you as a personal user. But as a developer, you should definitely know that these things are out there, and you should definitely know how to defend against some of these things. So let's continue on. So think about it. Browsers, when we explain it this way, okay, and again, if we go back to how the web started, which was just simply, I think it was document sharing, right? That's what, when Netscape was created and when the World Wide Web was created, it was just academics trying to share documents and information from universities and things like that. Okay, over time it has evolved, but now we have put browsers in this position where they're trying to run arbitrary code, right? So it's JavaScript, and we have a JavaScript runtime on every single device, right? So everything that can pretty much load a browser has a JavaScript runtime. Okay, so right there on every single browser there is a server running. Okay, and this server can execute any arbitrary code. Okay, just like it would on any other server. Okay, and as the browsers evolve and as we get access to more and more low-level APIs, then we have more and more access to really low-level resources, right? So it's not just resources across the internet. We also have resources right there sitting on your computer. Okay, and again, this creates a huge how can I say this creates a huge risk for anyone developing applications or any user using applications themselves if they don't know what they're doing. Okay, so the web at this point has this extremely ambiguous goal to run any untrusted code securely on any device, right? So you, being the app developer, you can control what the user, essentially the runtime on their machine, you can control what they do, even when they load your website, and that's important for you to understand, right? So even when someone loads your own website on their browser, because they have a JavaScript runtime running, then they can do essentially anything to your website. And we're gonna be looking at some of those examples on cross-site scripting or injecting code. But that's pretty much what we're dealing with here. Okay, when we're talking about the web and running random, any type of code on any machine. Okay, and we also have on top of that this idea of different sites interacting in the same tab. So let's say you have an ad company. So let's say you go to like Facebook or something, right, or any other company, and then on the side you see some ads running. Well, those ads are actually that ad agency injected a piece of code on that website to run. And again, if that and those two sites are two completely different sites that are, one is loading resources from somewhere else, and then the other side is loading resources from another place, and these two resources are making up the whole site. But the thing is that that you want to think about is that these two websites are running code from completely different places, and you don't always have control of the code that's running, right? So that's the idea, right? And that kind of gives us a perspective of what we're dealing with. Again, as the web evolves more and more, we have more and more access to low-level features. And low-level features, I mean hardware access. So as computers become more and more powerful, and then mobile devices, and the fact that users can be mobile and have these really powerful computers kind of in the pockets of everyone, and Wi-Fi networks, and all these things, come together to create kind of a perfect storm for hackers and people that want to get access to information without permission, right? So that's something that you have to be thinking about. Okay, while at the same time we have this desire as developers to create the best experience for our users, right? So again, we get back to this notion of the tension between creating a really great experience for the user while at the same time preserving the user integrity for their information, and making sure that our applications do not cross those boundaries between protecting our users from anything that they themselves might do or someone else might do on their behalf, right? So all these things, when the web was being developed, none of these things were being thought of, and we're gonna see some of those things as we get into the course. That we can see that some of these APIs that we think about on the web are so outdated, but because we want to make sure that we're not breaking any of the older websites that are still using a lot of this code, but at the same time we want to create new APIs that give us more access in a more secure way. The web is kind of left in this limbo state of having really old, buggy code that has vulnerabilities, but we can't change. While at the same time, websites that are trying to push the boundaries of what's possible on the web, while not not crossing any boundaries. So again, it's really an interesting scenario that we find ourselves when it comes to the web and to security. So let's the browser. When we think about the browsers, right, and the task that they're trying to provide is a really difficult thing to do, right? Because even malicious sites, okay, any website, even good and bad websites, here's everything that we have allowed them to do now, right? They can download content from anywhere, so anyone can pretty much write any website on the URL, and then you're downloading content, right? The fact that they're rendering even simple text from somewhere else, those resources are being rendered, and that code is being executed on your machine, okay, and on every user machine. So that's pretty much that's just the way the web works, right? That's just the way JavaScript works. So that's just kind of what we're working with, okay. We can also spawn worker processes, so we can, and with web services and service workers, now we can have code that's running on the background, right, and using even more resources that the user's even less aware of, right? So if you have these websites, and on mobile, it's even more, even more of an issue, because some of these websites even know where you are in the world at all times, right? They have your information, they have everything about you, right? So you can literally be at the pool or at the beach in some remote island, okay, and just by the mere fact that you're connected to the internet, someone else can know this about you, right? And if they have your information or your users information, then again, you can just see how this is again, I honestly, one thing I want to make sure that we don't do is we do not want to create this fear mindset, okay? We're just trying to go over what the web is, okay? And these are just the facts. These are great things that we all want, because we all want to deliver that great experience. But again, this great experience opens us up to these things that could happen, right? So again, you can opt out, live off the grid and go back to teepee huts, or you can decide to live, in this world, and again, it's only going to keep moving forward, and I think we can get a great experience. But part of this great experience comes with a little understanding of what we're dealing with, okay. Also, because sites can cross communicate, any website can pretty much open up any sockets to a server and keep that socket open, right? So that connection can stay open for a long time, essentially forever. If a site really gets if an attacker really gets access to a client's website or a user's website, and once the information that flows from there, or let's say someone logs into a public Wi-Fi, but then that Wi-Fi is actually an attacker spoofing some Wi-Fi or masking some Wi-Fi, then all the information that goes from your machine to another machine, all that communication can be intercepted, and someone can actually steal this information. And we've seen a lot of this stuff happen with not just attackers, but sometimes the attackers are people that you don't even expect, right? The governments have done this. We've seen this with the Snowden files. We've seen this with the Julian Assange stuff. And again, most people are unaware of how this happens, but this is just some of the stuff that could happen, right? This also, the web, we can display media in huge number of formats. So you can open up PDF formats, you can open up video, MP4s, you can open up MP3s, you can display and play HTML. So there's a lot of protocols that the web has to pretty much account for, okay? Again, you can run custom code on the graphics processing unit, so someone can really get access and start controlling the hardware and the software that your computer runs on, right? And they can essentially run your computer out of RAM, out of they can do, if they have access and it's a malicious attack, they can pretty much control your whole system. And at that point, if someone doesn't know how to defend against this, then you're at the mercy of that person. And you can, again, this is this is just something to know, but you can also save and read data from file systems. So yeah, if someone can access your database or private files on your computer, if they gain access, this is something that could happen and you should be aware of. So again, these are some of the stuff that we're going to be covering in the course, and it's important for you to understand just a little bit of what we're going to be the stuff we're dealing with when we're dealing with web security. So essentially, we come to this fork in the road where we have different visions of what the web was intended for, and what we've actually gone ahead and done with the web, which is again completely unintended, but because it has been such a great platform for delivering information over the years. I think this has been just the natural progression of things, and little by little we have come to understand some of the stuff that's good and some of the stuff that's not so good. So again, at the beginning, the web, all it was intended for was simple document viewing, right? It was just meant for text file and sending information. You have an IP address, and if someone, before even search engines, if you didn't know someone's IP address or where a resource was at, a website essentially, then you just didn't get there. But now, because of search engines, SEO, and all these things, things have become a lot more accessible. To the point that we've gone from simple document viewing to powerful application platforms. Okay, so the web today is a completely different thing than it was at the beginning. Okay, so the third goal of this course is learn how to architect secure systems. Okay, so now that we know what we're dealing with, okay, and now that we know a little bit of what we're going to be what we need to be tackling in order to understand what web security and how to really defend against all these things, this is how I'm planning to structure the course. Okay, so the part one is browser security model and the same origin policy. So in the part one of the course, we're going to talk about how the browser, okay, is structured, how the web, what actually is the browser, how the browser functions, and the security model that was implemented on the browsers and pretty much all browsers. So the standards that the specs have put out there for the browsers to implement. Okay, and we're also going to be talking about the same origin policy and why it's important when it comes to web security to follow this policy, and also how we can bypass the policy and how someone can attack this policy for cross-site scripting or injection attacks or any of the other attacks that we're going to be covering. Part two is client security. Okay, attacks and defenses. So we're going to be talking about how to secure data as data is being uploaded from the client and being uploaded to somewhere online. Okay, and then how is displayed on some other end. So again, if this data is coming from the client computer or or some code is running, okay, on a client's machine, how can that client be protected, especially if you're the web developer that's delivering the service or the experience of that client. On part three of the class, we're going to be talking about server security. And again, we're going to be covering the attacks. First and foremost, I'm going to be showing you what are going to be some of the attacks that someone can do. Okay, and then we're going to be going over some of the defenses to those attacks. And again, we're going to be covering some of the specs and some of the technology that have been coming online, such as authentication and TLS, also HTTPS, and a little bit into cryptography and how you can secure not just the client, but also when someone is making a request on your server, that you can guard against some of the attacks that can happen on the server side. And then the last part, we're going to be also, and this actually covers part 1, 2, and 3. We're going to be, as we cover the attacks and the defenses, we're going to be covering how to write secure code. Okay, so in the attacks, we're going to be actually going over live code, and I'm going to show you some of how to take advantage of vulnerable systems, and then we're going to be covering how to defend against these vulnerable systems so that you can actually go ahead and defend them for yourselves, and you can actually go help if you're interested in more depth and actually becoming a pen tester, how you can how you can become and do this yourself and actually make sure that no system is vulnerable and where to look for these vulnerabilities yourself. So the first thing, so now that we've covered essentially a little bit about the web, kind of what the web was intended for, and what it has evolved into, let's go into the three main pieces of what we're going to be dealing with when we come into web security, and what are going to be these things and why these things are important to understand. So the first thing is HTML. And again, I know this might be a review for some of you, and if it is, I'm sorry. It's just that you might have never heard of it from a security standpoint, and I think it will be enlightening for you to to listen to this part of the course, even if it seems like a review. So again, I was able to pull up this image from back in the day. This was Netscape, and I think this kind of gives us an idea, right? Because sometimes we tend to forget exactly where the web started. But just remember this, okay? This is really what browsers were like, okay? And all they had was simple buttons or links, that link to places, and just some like text and image. That's all you could do at the beginning in the web, right? Now it has evolved into a lot different. Now we can pretty much even have 3D experiences with things like Oculus and Quest. So the web has evolved from this to imagine having a full immersive experience like 3D personal computers, right? So I don't think anybody had that in mind when they created Netscape, okay? Maybe some people did, but I don't think we could have understood at that point the speed at which all that was going to come, and I think it's only going to progress even faster as we move forward. Okay, so again, HTML is really made up of these tags that the browser needs to understand, interpret, and then process and render. Okay, and that's where the code has to be executed on the client side. So when someone requests some resources from the internet, this is pretty much what gets sent back to them from a server, and this is then the server goes ahead and gets this HTML, okay, and renders it to the browser. So let's from there, what we understand is it brings us to this natural conclusion: is how do we access things on the web? Okay, and we access them through these things called uniform resource locators. Okay, and these are URLs, and the URLs are made up of a few pieces. Okay, and let's go over each piece now so that we understand later on when we are accessing resources from the internet, how these resources come, how we can access them, and then how the web actually goes ahead and renders them and processes them and interprets them. So the first piece is the HTTP or the S or any other protocol that you might be using. So there are different types of protocols. In this class, we're going to be talking about HTTP because that's the main protocol for the web, and this goes over the TCP protocol. But it's pretty much built, it's hypertext protocol, which is, again, if we look back to this to the screen, this is pretty much it, right? So it's the protocol that displays images, videos, text, that type of thing, right? So like that's what the web understands, and if you give it this document in this form, then it will render it in a way. All the browsers have implemented the standards in order to render the web the way that we see it today. Then the next thing is the host name. So the host name is pretty much because we have a DNS in the middle, and we have these really simple domain names. Later on, what happens behind the scenes, and we'll go over this in future courses, is that it gets translated into an IP address. But that's pretty much what the host name is. It's where this resource that you're trying to access lives, right? And the host name is pretty much a really simple way for people to pass around information and say, hey, here's where this resource that you want to get is at, right? In this case, we're using example.com, but you can just imagine facebook.com or any other thing. That's pretty much what we're saying when we're typing in the host name. Then the next thing, which is usually excluded from most from when we type in a URL, but it's always included implicitly when the actual search happens, which is the port number. And for most resources online, is port 80 if you're going through the regular URL. But again, a port number is just where on the server does the resource lives. And again, I think well, for most things online, is port 80 is the port that things live on. Then after that, anything that comes after the host name and the port, followed by a slash, that whole part becomes the path, right? So again, although things live on that host name, we can actually link to different pieces of that host name. So different parts of that host name, if we want to access a certain resource, that's not just the main homepage, right? And that's the path, right? And again, most of these things are done implicitly. So if you visit the homepage and you don't include the path, well, then the path is included for you by just a forward slash and nothing after it, right? And that's just the path that you have access. So that would be the homepage or the index page. Then anything followed by a question mark is the query. So this is one way to pass around information from the client to the server. And we'll see when we submit forms and things like that. Forms take advantage of this aspect of the URL, and they can pass around. Again, sometimes it's something very simple like a user and a year. Sometimes it's the way we want to display the information. So if we're trying to sort it, descending or ascending, we might pass the stuff within the URL so that we can then access it in a meaningful way from the server side. And then anything followed by a hashtag, this is called anchor tag. So because, and again, this can be used in videos, but also in websites when you want to bring a user to a specific point within a URL, right? So within an HTML document, if you want to, let's say, bring a user to a certain piece of that document, maybe halfway through or something, then you can create an anchor tag and include it in the URL. And then what the URL will do is it will bring that person specifically to that point in the document that you specified. Okay, so, and this is pretty much how all URLs are constructed. Some of them have all these pieces, some of them have just some of the pieces. So everything pretty much needs to include the protocol, the host name, the port, and a path. Okay, and again, some of these things are included implicitly. So just because you didn't include the port or a protocol, behind the scenes it still gets included. But that's pretty much what everything needs. And then again, this is what a full uniform resource locator looks like, and this is how everything on the web is accessed. Okay, so now that's an important thing to keep in mind. And this, from this point, then we get to this point, which is what gets returned from the server. And again, as long as it's it gets at the top level, it gets specified as a doc type HTML, so that way that the browser knows, hey, this is something that I can render. I understand this thing, and then the browser parses this information, and then it shows it and displays it to the user. So pretty much, an HTML document is made up of a lot of tags that the specs, so the committees have gone ahead and they've specified these tags that all browsers pretty much follow. And that's pretty much what every single HTML document is made up of, right? Image tags, video tags, audio tags, canvas tags, link tags, style tags, which again, these are going to be pretty important because this is how pretty much code is executed on the client side. So this is how JavaScript can be executed with link tags or script tags. This is how we can load in CSS tags. This is how we can load in image tags, and we're going to be looking at how these tags can become vectors for attacks. Okay, and how they can be exploited to run code that was not intended to be run, or code that accesses things or resources that was not intended to be accessed. Okay, and but pretty much that's pretty much how the document is made up, right? So every HTML document is made up of tags, and the tags are, again, these are just resources. So every single video will have a source, an audio file will have a source, canvas won't have a source, but it'll access resources within the machine. An image tag will have a source, a link tag will have a source, a style tag will have a source, a script tag will have a source, or it will be inlined in the actual document. So with these tags, for example, we can include CSS. This can be external, so a link tag that has a reference through an href means that you can load in external files into this into any website, right? So not there are some things that could happen through CSS as a vector attack, but most of the attacks, most of the things that you will be encountering, we're going to be covering in the course, will be through JavaScript, because JavaScript, again, is that runtime, that execution runtime that's on every single device, pretty much anywhere in the world, right? So because every device has a browser, and every browser can run JavaScript, then this is pretty much the largest vector for attacks. Okay, and we can see how JavaScript can modify the HTML document. We can also load JavaScript externally, or we can inline it, as you see down here in the script, within the script tags. Okay, but in all honesty, JavaScript is a lot of fun. Okay, so yes, we are going to be covering how JavaScript. A lot of people like to rag on it, and a lot of people like to talk smack about JavaScript. But again, remember, JavaScript is the language of the web, right? So JavaScript is pretty much the number one language that's executed around the world. So it's really, really important to understand JavaScript. And because of this, and because a lot of people still don't understand JavaScript completely, and it's misunderstood, and because it was a language that was written, I think, in 10 days when it was written, it does have some things that are that make it maybe not the best language when it comes to security. Maybe it's not like Haskell or something like that. That's a lot more thought of and super mathematical, and it's dynamic, and you can pass functions around as closure and all these things. There's a lot of things that can go wrong in JavaScript, but it's a fun language. It's flexible. It gives us immediate feedback. It's also pre-installed on every device in the world. So again, it gives us the most flexibility, and it gives our applications the best chance of living without going through any app development process, right? So you don't have to go through a marketplace. You don't have to, ask permission. You can pretty much every single browser that's already installed can already run JavaScript. And because of this, pretty much any website that we can create, we can run, just host it online, and it'll run on any machine. And that's an incredible thing, right? That it really is. When you think about it, that is one of the most amazing things that we have ever created, and that's one of the things that I think we should protect. But again, it does open us up to some risk vulnerabilities. But again, just something that we have to deal with, and just something to note. It's also dev environment is pre-installed too, so it's easy to start writing code. So we're gonna see we have an inspector built right into every single browser, and because of this. One of the things that we need to understand is that we definitely cannot control what the users do, even when they load one of our websites into their machine, because at that point they have control of the website, and they can pretty much inject anything they want, or send something to our server, or any of these things that we have no control over. So once we have rendered on the client's machine some code, then at that point they pretty much have access, and it's running on their machine, so they also have access to a runtime. And again, this they can send some information to our server, and our server has to know how to handle all these things. So Node.js, on the other hand, is JavaScript that runs on the command line. Okay, so not just does JavaScript run on the client side, so not just is it installed on every single browser, as of a few years ago, on the scene, and now it's been a while already. But then came Node.js, and Node.js pretty much is JavaScript on the command line. So this is a backend language, language, kind of like a server-side language like Ruby or Python. Not that again I'm comparing JavaScript to any of those languages, but just to illustrate the concept, is that JavaScript is a language that runs both on the client and on the server, right? So it's probably it's the only language, right, that the browser understands, and it's also a language that can run on the back end, right? So this, because of Node.js, this brought us built-in functionality for the file system. So through Node, and because it's a server-side language, we have access to, again, the file system. We have access to HTTP, DNS. We can open up sockets. We have crypto access. We have pretty much access to the full machine, right? So we have access to the full server through Node.js. And again, this makes JavaScript, again, very, very powerful. And the fact that it's running on every machine, again, just all the more powerful. And again, I think it's a lot of fun. I personally love JavaScript, so I'm a little biased, but this is what we're going to be covering. So I hope you're strapped in, because it's going to be fun. So stuff that belongs in scripting languages, but not in the browser, is what we can do with Node.js. And for this, Node.js is it's a great language, and I think everyone will do well to learn it. And we have a few courses, so you can if you want to learn a bit more about Node.js, then check out some of our other courses. Also, Node.js added a module system, so we can, just like we did in the browser, we can load resources externally. We can also execute binaries through Node.js. So again, this just made JavaScript even better. The fact that we can write it on the client and on the back end. And then when we talk about JavaScript, because it runs on the client, it runs on the server, and pretty much anyone can write a package and then publish it, and then some other server can load this package externally, and you don't always have control of who's loading the resources, who's publishing it, and who's running the code, or where it's running, what context. So because all these things are sort of arbitrary and it's such a large vector space, JavaScript has a lot of APIs that we're going to be covering in the course. But these are the things that make it kind of a great space to do some hacking. Okay, so the JavaScript APIs can come from a few places. For example, they come from the JavaScript language specs. So this is what ECMAScript and the TC39 committee actually focuses on, and you can read up about any of the specs from JavaScript and the language itself. But then also when we execute JavaScript on the browser, then that comes with the whole set of APIs that are just browser contextualized, right? So so if you use jQuery or React, then that's JavaScript on the browser side, and then that JavaScript has access to things that's not necessarily accessible through the server. So for example, we have access to mouse events, forms, submissions, and fetching APIs, and all these things that are not, are just part of the DOM, but not necessarily part of the server, right? And then when we go to Node.js, we have things that are part of the server, but not part of the DOM. Like for example, creating servers. We can, create an HTTP client. We can access the file system. We can, do all these things that are part of server-side languages, but not part of client-side privileges. And examples of this are array. So an array is something we can use on both the client and the server. Document.createElement. So an array is part of the JavaScript language itself, right? So that's part of the language as a whole. But then we have things like document.createElement. That's just part of the DOM API, right? But then we have fs.readFile, and that's something we can do on the server side, but that's not something we can do on the client side, at least not explicitly. There are ways around this, but again, we have to exploit a piece of JavaScript that wasn't specifically made for that. And that is what we're going to be covering in this course. And we're going to be covering how to attack those vectors and then how to defend against those attacks. And again, these are some of the older browser APIs. And I want to end this part of the section here. And then we're going to be actually going over and getting started on some of the attacks on the browser side. So window.open, we can create pop-up windows. We can pretty much create things that are, for example, link. We can move the windows around. We can resize the windows. We can share in real time through WebRTC information. We can even get camera access, microphone access. I mean, it's really the Wild West when it comes to JavaScript, and in my opinion, it's a lot of fun, but it's also very risky and does open people up to a lot of risk if they don't know what they're doing. And again, because JavaScript is in every single device, you can kind of get an idea what we're going to be dealing with. So anyways, I hope you're excited about what we're about to get, about the journey we're about to take. I'm excited. So again, if we need to go over this introduction again, I know we covered a lot. We're going to be going kind of at a fast pace, but I want to cover a lot in this course so that you feel by the end of it that you understand the theory behind what we're talking about. You understand the practice, so how to, and then you understand the attacks and the defenses that I want to teach you. So that way you can actually go ahead and implement it. You can go ahead and get a job if you need to on as a pen tester, or if you want after this class, then you can take a more in-depth class into web security or just security as a whole. And I just hope it helps you out. Okay, so anyways, I'm excited, and I'll see you in the next class. Okay, let's go over a few attacks before we get into it, just so you can see how dangerous this can be and how you can, or someone can perform some of this, and then how you can defend against it. Now, the first one that we want to cover is the session hijacking attack, okay? Now, I'm over here in one of the browsers logged in to Netflix, okay? And again, this is just a regular Netflix. And what the attack is going to try to do is it's going to show what happens if someone gets access to a user session and how they can take over their identity on the web. Okay, so I'm going to go ahead and open up the console, and then we're going to go over to the application server, the application tab on our server, and then we are going to, so again, remember, on the left side we're logged in, on the right side we are on an incognito window. Okay, so we're definitely not logged in, and it has nothing to do with the account on the left side. But what we're gonna do is, over here we're gonna come, and then we're gonna grab these two cookies that Netflix has set, and then what we're gonna do is we're going to just copy them over into this other Netflix account. And again, let me just refresh this account so you can see that I am not logged in, right? So although we have these two cookies, this is not an actual valid, this is not a logged in account, whereas on the left side, we are logged in. So I'm gonna go ahead and just grab these two cookies, okay? And then I'm gonna paste it. I'm gonna paste the first one, and then I'm gonna paste the second one, okay? Perfect. And now what I'm gonna do is I'm gonna refresh this page on the right side, and let's see what happens. So as you can see, now on the right side, okay, without actually knowing what this user's, let me just pause this, without actually knowing what the user on the left's login info is, okay, all we had access to was their cookies. And on the right side, if someone were to inject some malicious code, and if someone were to pass this information around into their server or get their hands on it, then you can see how they can, in this example, we showed something pretty benign, which is just logging into a Netflix account, but you can imagine how this can be used to either log into your Gmail or a bank account, or even some company information. So again, these are this is what happens with session hijacking attacks. And in this course now, what we're going to be doing is we're going to be covering the defenses and how this attack actually takes place. Now I want to show you another attack just so I really want to drive home the importance of protecting, not just your identity online, but your users' identities online if you're a developer. So over here, we're gonna do something very similar. So on the left-hand side, I'm gonna make this window just a little bigger, okay? And then I'm gonna bring this down. So on this page, okay, we have two servers running. Now I'm gonna go ahead and show you the code. One is the victim server, and then the other one's the attacker server. And what we're going to show is we're gonna demo. Imagine if on one side we had a secure bank. Imagine this was a bank, and on the right side we have an attacker that was able to implement not just a session hijacking account, but through the cookies, they're able to post a form to the server, to the victim server. And because the victim is logged in on one or their accounts, then they can perform actions on behalf of the user. So let's see how that works. So, and again, one of the things we want to make sure that that we're looking at is over here we're actually logged into two servers. Okay, so this is a cross-site scripting attack, and we're going to cover this more in detail in the class. But you don't have to be logged into the same server at all. So these are two completely different servers. Okay. And then what I'm going to do is I'm going to go ahead and what we're going to do, it's over here, we're going to log in as if we were a user of this bank, okay? And we can see that, again, just like a normal bank, you have your balance, and then you have this form over here that you can transfer money to someone else, okay? Now, the attacker, what they've done is they have actually, imagine if someone gave you a link, or if someone was able to get you to click on a link that gets you to a different website. Now, once you're on that different website, imagine that this form was actually hidden. Okay, now we're showing it not hidden over here to showcase the example, but this will be on a different site, and the user wouldn't even know that this would be actually happening. And with JavaScript, we can actually automate this whole process. So over here, we have a client that's logged in, or at some point they're logged in, so they have a session running with within their bank, okay? And now they've kind of clicked away from that bank, and now they're on to another site. And on that site that the attacker sent, that the attacker has hidden this form, okay? And what they're going to do is we're going to perform the attack just so you can see how it happens. So I'm going to go ahead and transfer $500 to another. Let's say in this case, we're logged into. We're going to use
the Alice user cookies to send $500 to Bob. Okay, and then we're gonna go ahead and click on transfer. Okay, and again, imagine if this was hidden. So this is not something that's actually taking place with the user knowing. And then what we're gonna do is we're going to refresh the actual bank website. So next time Alex comes and logs into their account, they're gonna see that their balance is 0. And what we've done is that we have actually, okay, and if we check over here on the network tab, we have actually performed an attack, and I'm gonna refresh it, okay? And because this person at a previous time, they were logged in into the, let me go over here and then log in into the network tab. So you can see, so yeah, over here in the network tab. So because this website, and actually what we want to do is just click on the application tab just so we can see the cookies, and then over here as well. Okay, so because this attacker has access to this session ID, okay, and then the session ID is not protected in any way, anytime someone on any other website, okay, as long as the session ID is valid, okay, and the attacker, if we look over here at the attacker form, okay, we can see that they're making a request, a post request to this localhost 4000, which is where the bank website is hosted. Okay, now when they make the request, since this person was actually at some point, and this request again can come from any website. You don't have to be logged in. It doesn't even have to be from the same bank account. This is just the way the web works, okay? And how cookies work. And what I'm going to show you is how you can defend against this attack. But because of this, okay, any request, okay, that gets made to this server over here, okay, what the website is going to do and what the client's going to do is it's going to include any of the cookies that are on that machine. And in this case, right, because this although it's the same user and we have this cookie, but we're on a different website, then when we actually go ahead and make the transfer amount, okay, we're going to go ahead and see that the transfer got made, and not just the transfer get made, but included with the transfer, okay, we have actually gone ahead and included the session cookie, okay, even though over here we don't have any access to it, okay, because we're on a different domain. It got included because at some point that user also had logged in into their bank account. So again, these are two ways that session hacking can happen, and I wanted to go over the attacks. And now what we're going to do is we're going to go ahead and set up the attack, see how it works, and see why it works and how we can defend against it. Okay, now that we have gone over the session hack, okay, now that we've gone over the session hijacking attack, what we want to do is we want to understand how did that attack happen, what about the web makes it vulnerable, and how we can defend against that attack. So what's the first thing, okay, when we talk about the web, what exactly happens when you type in a URL, okay? And that's the first thing we need to understand, and that happens at the DNS level. Okay, so the domain name system, and that's what the DNS is, okay? So anytime that we're on our computer and we're typing a URL on the URL search input, okay, so if you go to Google and you type in a URL or something like that, what's going to happen is a few things are going to happen. Every URL that you type in gets forwarded, okay, or gets translated into an actual IP address, okay? But at first, we don't know what that IP address is. So let's say you're going to example.com, okay? So the DNS resolver, which is usually issued to you by your ISP or a router or something like that, this DNS resolver, it's recursive. And the first thing it's going to do is it's going to say, hey, from your computer, you're going to say, I want access to example.com. So you're going to go from the 1 to the 7 over here, okay? But the first thing is the DNS resolver doesn't actually, is not in control, or doesn't know what that IP address is. So it's like, okay, I see that you want to go to example.com, but first I need to know where that's located. And I don't know where that's located. So the first thing I'm going to do is I'm going to ask a root server. And the root server is going to come back and tell you, is like, I don't really know where that is either, okay? So what's the root server, what's their functionality? Well, the root server's functionality is to accept recursive resolver's query, which includes the domain name, okay? And the name servers respond by directing recursive resolver to the TLD server. So what the recursive server is doing at this point, the root server is going to say, hey, I can see that you're trying to access a .com domain or a .net or .edu or whatever, and it's going to tell you, why don't you go and ask the TLD server? Okay, so it's going to send you and going to redirect your DNS resolver to a TLD server. Now, the function of a TLD server is to maintain information for all the domain names that share a common domain extension. So a .com or .net or whatever comes. So it's going to start from the right to the left. Okay. So once we get issued from the TLD server, it's going to tell us, okay, you got the .com. Okay. But I still don't know that where example.com is. Okay. So I'm going to go ahead and send you to an authoritative name server. And the authoritative domain server is now that we have the TLD extension and that we have taken that IP, okay, where this is going to be located, now we have everything we need in order to ask the authoritative domain server what the IP address of this specific URL that we're trying to access is. And the authoritative domain server contains information about a specific domain name it serves, right? So it can provide a recursive resolver with the IP address for that server found on the DNS record. Now, if a domain has a CNAME record, it will provide the recursive resolver with an alias domain, at which point the recursive resolver will have to perform the whole DNS lookup to procure a record from the authoritative name server. So all this really means is, at this point, now that we have the authoritative domain server, in this case, example.com, is going to come back to us and say, hey, I'm example.com, I'm the authoritative name server, and I actually know what the IP address of example.com is. So now we can actually translate that that the way it was written, which is human readable, right? Example.com into the 1.1.1.1 IP address that we're looking for. So essentially, what happens when you type a URL and press enter, just to recap, is that the client has the DNS recursive resolver to look up a hostname, okay? That DNS recursive resolver sends a DNS query to a root name server, okay? Now, the root name server responds with the IP address of the TLD name server, okay? The DNS recursive resolver sends DNS query to TLD name server, okay? So now that we have the root name server, okay, which again keeps a record of all the TLD name servers, and then after that, the TLD name server is going to send us to a DNS recursive resolver to an authoritative domain, and that authoritative domain is going to come back with the full IP address of the domain we requested, okay? And that's how a DNS domain name system works, and that's the first step, okay, in any query that happens on the internet. And that's important to keep track, okay? That's important to understand because if you remember at the beginning of this class, we talked about how browsers work, okay? Now we're going into how the network works. And the first step, okay, from your browser to the internet and to access any of the files, any of the resources that are hosted on the internet, this is the first step. So it's going to go over our DNS resolver, okay? Now, your DNS is usually something that it's like a router, or if you're, let's say, on a Starbucks location or at a coffee shop or somewhere public that you log into a Wi-Fi network, then they have a DNS that you know, anytime your query comes in, right, it'll go through their DNS resolver, and then they'll bring back to you what the actual IP address. So all the DNS resolvers work in exactly the same way. They go to the root server, TLD server, and then the authoritative name server, and then they return back to the user the actual resource that the user asked for at that point. So let's talk about really quick some of the attacks that happen at the DNS level, okay, which is at the very, very low level of our first interaction with the web. So the first one is DNS spoofing. So let's think about how this happens. Let's say you are at a public coffee shop, okay? And then someone, an attacker over here, injects a fake DNS entry, right? So whenever we're going to go ask the DNS, hey, where's example.com? The DNS server is going to say, hey, I know where that is. And it's going to point back maybe to a client that the attacker controls, okay? And then what the attacker is going to do, they're going to request whatever the client requested on their behalf to the real website, and then what they're going to do is they're going to return that back to the client. But because the attacker has inputted themselves in the middle, okay, they can spoof that address that they get back from the DNS, so that real IP address, they can spoof it and say, hey, you know what the IP address is? It's me again. So because the attacker is going to say, hey, it's me again, next time we go and ask for something back from the DNS, it's not going to go to the real website, which is what the DNS should have resolved. It's going to go to the attacker website. And at that point, the attacker can clone the website, not just clone it, but then inject code into their into that DNS entry, into that resource that they got from the real website, and then return it back to you. But what the client doesn't know is that this attacker in the middle, they have actually injected some code that didn't come from the real website. It came from a fake website. And that's what DNS spoofing is, okay? And that's what we need to be really careful when we log in into public Wi-Fi's. This is something that a lot of people do. So if you should be careful. And there are tools to check the DNS spoofing. Now, again, if you're in a reputable place and you know this place, it's not so much of a thing to worry about. But this is the first place where attackers come and something where they can start injecting code into your code base, right? So again, DNS spoofing is just cache poisoning. So the DNS, once it resolves an IP address, it caches it. Okay, so the next time we're gonna go ahead and ask other resources from this real website, it's just gonna say, hey, I know where that is, but it's gonna go to the attacker because the attacker spoofed their IP address and say, hey, I'm the IP address. Okay, but now the attacker knows what the real IP address is, but you don't, right? So then they can perform all the requests on your behalf, and then at that point, then they can inject any code on the website. So the next one is DNS tunneling. So DNS tunneling is a little bit different than DNS hijacking. So what happens is, let's say you're on premise, right? So you're behind a firewall of some kind, right? So you have a business, and but there is a computer that logs in into the network of that business, maybe a VPN or something. And what happens is, as we're sending packets over the web, so as we're sending information over to we're asking resources online, so we're going to different websites, we're going to maybe log in into a Dropbox or a Gmail or any other website that you log in. As those requests are going out, we can attach packets to the request, right? So the packets are what's going to be encrypted and then decrypted at the other end of this website. So if you're sending traffic over HTTPS, this all the traffic is it's pretty much encrypted at that point, and it's secure. But if someone is in your network and has some malware, then they can use the DNS as a transport layer, which is not what it's intended to be. But because DNSs perform so many queries, then they can attach to each of the queries a little packet that actually gets out of the network and then goes to an attacker's infrastructure. And once the attacker has that information, then they can extract information from inside the premise, or pretty much at that point, it's a vulnerability attack, and any data that the attacker set up on the infected machine can come through the DNS as a transport layer, and the attacker can get access to it. Okay, another attack that we want. This is one that we just went over, and it's pretty similar to DNS spoofing, but whereas DNS spoofing and DNS hijacking, where they differ, is that DNS spoofing actually attacks the cache of the DNS, right? So if you remember, when we perform our DNS resolver, the resolver at the end, once it gets the IP, is going to say, hey, next time you ask for the same example.com website, I'm not going to go through the whole song and dance, right? So it's not going to go through every step of the going over to the TLD, the root server, and then the authoritative name server. It's just going to look at its cache first, and it's like, oh, I already know what this is, so I don't need to go through all that, and then it's going to return the resource, right? It's going to just return the IP address. So that's where DNS spoofing, the attacker attacks the cache. In DNS hijacking, the attacker does not attack the cache, but instead it injects himself or herself in the middle, and then every single time someone asks for a resource, is going to say, hey, I'm that resource, and then it's going to perform that request on behalf of the user, and then return whatever the user wants. So it's very similar to DNS spoofing, except that it's happening for multiple domains. So this could be something that if actually happens, then that attacker could essentially snoop on the traffic, on all the traffic going through that network, and then they can do whatever they need to do, or whatever they want to do to the response of the user. Now the next one, is NX domain attack. So the NX domain attack, this is not so much about injecting code on a to a user on the response. This is more, let's say your business hosts a website, right? Maybe like PayPal or something like that, or any other website for that matter. What the attacker is going to do is they're going to do a denial of service attack. So they're going to inundate the DNS server, okay, with requests. So now that they have access and they know the IP address of the DNS server, they're going to ask it for records that don't exist, okay, in an attempt to cause the denial of service for legitimate traffic. So although there is although most of the people that are going to that website are just regular requests, there are these other requests that are very hard to detect the difference within the DNS because they look just like regular requests. But the difference is that these denial service attacks, they're asking for resources that are not on the server. So because they're asking for resources that are not on the server, when the DNS tries to resolve that, it takes a lot longer than when it actually finds a resource, right? Because it's going to look, and then it's going to look through the whole kind of map of that whole website. So depending how big that website is, this can take a way longer for that response to happen. And then because it's a denial of service attack, it can even be distributed. So if it's distributed, then that DNS for whatever that URL is going to get then inundated with fake traffic. And when a regular request comes in, then they're not going to be able to get the response back, and it's going to either time out or or it's going to be a denial of service on the host access, and you won't be able to respond with an actual with your actual website, right? And that's how the attack takes place. And the phantom domain attack, the main difference is the attacker sets up a bunch of phantom domain servers, right? Which either request very slowly or not at all. They're going to ask for resources that they know are on the server that take up a lot of, so let's say it's a 3 megabyte file, right? It's a 3 megabyte image or something. So what they're going to do is they're going to request that image multiple times, thousands, millions of times, depending how they set it up, the attack. And then they're going to try to make the same attack, which is denial service. And this is, this can happen for companies, big companies. Maybe you've heard in the news how companies are getting hacked. This is one of the attacks that someone might perform on the DNS at the DNS level. And then the botnet attack, getting any one of these attacks and then creating an automation for them. So a bunch of bots or a bunch of servers that once we have access to the DNS and the actual IP addresses, then we can just go ahead and automate all that. And instead of coming from one machine, right, and trying to inject code, then the attack will come from many machines. And essentially is going to try to overwhelm the host server. And then the host server is either going to create a denial of service, so it won't be able to host itself. Okay, so moving on from DNS attacks. And again, I hope that going through those attacks, I know we went through them quickly because it's important to know them. And you might not think when you're creating your website that we need to start at that level. But again, if we don't understand the whole process of how the whole web has been created, then that's exactly where we become vulnerable to these types of attacks. And more and more, again, as we have this tension in the web of we want to create just simple document, right? Just very simple standards that everyone can adhere to on the other end, we want to create the web so that it's actually a very powerful platform with many built-in APIs that most applications that we create don't hinder the user. We also have to become aware that with that power, we open up the web to allow more to allow more attacks. Okay, so I think web security in the future is going to become, if not more important than network security, just as important, just simply because the way the web is moving in a direction that websites are not simple documents anymore, right? They're full-fledged applications, and as computers get even more powerful and a lot more of the processing can happen on the client side instead of on the server side, then we can see how these attacks really can affect a system once someone either has been able to inject some type of code or run some type of code on your machine, on your code base, right? So now that we know the first thing that happens when you type a URL and press enter on the web, let's move on to, which is the first step, is DNS. Then what happens at the HTTP level, right? So we know the DNS and the resolver and the attacks that can happen at that level. But then let's talk about, which is what most of this most of the rest of this class is going to focus on, okay, which is HTTP, and which is the protocol of the web, And pretty much when you write an HTML document, this is where it gets transported from the HTTP protocol, right? So let's go over the HTTP protocol. Let's see how it works, and let's see some of the vulnerabilities that are built into that protocol, and how we can exploit some of them, and then how we can defend against some of it. So HTTP is actually a very simple protocol, and I'm going to go ahead and I'm going to go open up my terminal over here, and what I'm going to do is I'm going to go curl, and we're going to curl a very simple let's just curl let's see here, HTTP as www.twitter.com. Let's see here, did I write that correctly? I put 4 W's, it's 3 W's. Okay, here we go. So whenever we go to a website, okay, it's going to issue an HTTP request over a TCP socket, right? And in that request, if we focus on this side of the request over here, the request is going to be using, it's going to have a few things to make the request happen. And anybody can write a very simple HTTP client, and all you need is pretty much these things here. So you need the get, the type of request it is. This is a get request. Well, we're requesting the path is the path is just the home page, right? So this would be a different path if it was a different home page, if it was a different resource on that domain, and then the version of the protocol. So in this case, we're using the HTTP protocol, and we're using version 2. So you can imagine if we're trying to get a video, it might be different MP4 or something like that, but it's going to become that request is going to come over HTTP as well. And then we actually have to identify what the host is. In this case is twitter.com, and the user agent in this case is curl, but otherwise it would be like Mozilla or Chrome or something like that. Okay, then the response we get from that, it's also very similar. Okay, so I'm gonna make that request again just so we can get the full version of Twitter and not truncate it. And then what we're gonna be going over, so we're over here. So in that response that we got from Twitter, we got a 200 response. Okay, and we did the same thing, curl v and HTTP twitter.com. Then what happened is, so in the response header, let's go over what response we got. So we got an HTTP. Remember, the request is using HTTP2, so the response is going to come back as well with an HTTP2. So again, the request and the response at that level, they're going to match. Then we have a few headers over here. Cache control. We're going to go over some of this. Content length. So the length of the response that we just got, right? So this is pretty much the Twitter website, the HTML content. The content type is text HTML. Again, this could have been MP4. This could be maybe a torrent URL, which actually brings the packets from many different sources. So it's a different type of a protocol. In this case, we're using HTML. The date when this was performed, any expiration for this, and then last modify. So if we're doing any caching, it's gonna say on it's gonna say, hey, cache this website. Again, we see here that has a header that says no cache, and then we see a few more headers that are setting cookies, right? And then we're gonna go over all this, and that's pretty much it, right? So we get an HTTP response, a few headers, and then after the headers we get the payload, right? So pretty much the response. Okay, so let's so that's pretty much what happens when we make an HTTP response, right? So the request, like I said, you have to specify the method. There's a get method, and there's a few. The most common ones are get, post, and put. Then the path, in this case, is the homepage. So we're just gonna put a slash, and then the version of the protocol. We can use over here HTTP 1.1, which still on the web a lot of websites use. But we saw that we already have HTTP 2, and I think HTTP 3 is even coming down the pike. So and then the rest that we the next thing we have to include in the headers in the request is any headers that we want to include. So the host developer.mozilla.org. So that's not optional. That's mandatory. So we have the path over here of what we want, but where, of what host? Well, okay, of mozilla.org. Okay, so we're gonna go to developer.mozilla.org, and then we want the homepage of that, and then that's what we're gonna resolve through the DNS, and then any other headers that we want to include. In the headers, we can include cookies or a few other headers that are pretty common, and we're gonna go over those as well. And then some the response, it's again very similar to the actual request. It's going to bring us back what type of response it is. So the version of the protocol, right? The status code. So if it's a 200, it's like, okay, we got a response back. That was everything. Everything went well. The status message, which is okay. Again, these two things can change, and depending on how they change, uh, it tells us something different about the response that we got. And then any headers that want to be included in the response. So the response and the request, they both look very similar. And again, like you saw, there's not really a lot of magic. Anybody can create an HTTP client and start making requests to a server. So again, if we remember, the main model of the web is a client-server model, right? So that client adds the server for resources and the server replies, right? It's pretty simple. It's human-readable text protocol. So if we look over here at at Twitter, this is HTML, but essentially, you can just write from any text editor that you like, and you can just start kind of hacking away on writing HTML and then sending it over the wire. It's also extensible, so just add HTTP headers, and as you can see, the more headers, and over the years we've kind of included more and more headers in the spec. But any header that a browser wants to accept, they can pretty much, or a client or a server wants to accept, they can just write it in. And as long as you know what the headers are and you send the header, then that client can respond and actually understand the header. So it's not something that's written in the spec. Anybody can pretty much add any headers they want, and in this way we can make it not just something that's standardized, but also something that's extensible and something that we can grow depending on the needs of any individual client. It's also stateless, so two requests have no relation to each other. So remember, as we're sending packets over the wire, pretty much as you can see, the get and so the method, the path, and the version of the protocol, that's pretty standard. The host is pretty standard. So everything has to be included every single time we make a request. There is no state that we actually have embedded within the HTTP protocol itself. Now we can add it, and we're gonna go over one of the ways to do that, and cookies is one of the ways. But again, that's not something that's part of the protocol itself. That's just something we add to the protocol in order to actually have state and, for example, login or anything like that. And as we saw, because of this, we can perform certain attacks like session hijacking and stuff like that. But again, it's not part of the HTTP protocol itself. It's something that we can just tag onto it, and it's a transport or protocol agnostic. So the only requirement is reliability. So over the transport, you can pretty much send anything you want, right? In this case, we're sending a simple HTML document, but as you can see on YouTube or any other video site, we have videos. You can send PDFs. You can send whatever you want. So it's pretty much protocol agnostic. And the web in the state it's at, it really serves a lot of extensions. So it's not just a simple document viewing platform anymore. It's become a lot more than that, right? So, like I said, now we mentioned that HTTP is stateless, but obviously we do interact with stateful servers all the time, right? So when we log into a website and we come back to it, and that site remembers our login information without us having to re-enter it, then how is that happening, right? So if we said it was stateless, but at the same time we know we log in into different websites, and the sites somehow remember that information. So again, we're going to get into that as we go into cookies. So stateless in this case means that the HTTP protocol itself does not store any state. Okay, if state is desired, is implemented as a layer on top of the HTTP protocol. It's not something that's baked in. Okay, so that's very important to understand. Now let's go over some of the HTTP status codes. And again, if I were you, for me, the first time I remember learning this, I didn't really know. Now as a developer, you get pretty used to some of these codes. You get accustomed to seeing one of them, some of them more than others. But I think it's helpful to understand, at least have a basic understanding of what each of them mean on the web. So we have the ones that are in the range of the 100. they're pretty much informational status codes. In the 200 range, there's success codes. So we saw that we get a 200 success okay. So that's pretty much when we make a request and everything goes well, and we get a 200 back. At 300, it's a redirection URL. So that tells our, when we're dealing with the DNS resolver, it tells the resolver, hey, this page has been moved, and you can find it over here. And then usually it'll tell the DNS where to go to find that page at that point. At 400 error, I think everybody's used to this, seeing a 404. This is on the client side, there was an error. And then a 500 error, it's on the server side. So the 400 and the 500, they're both errors on the resource that we tried to access, except that the only difference is that the 400 is on the client side, the 500 range are on the server side. So let's go over some of the success codes. 200, okay, it's the request succeeded. Here's another one that's common and you might see, especially if you're dealing with, let's say you're sending a whole video over the wire, and you want to start the video at actually minute 1. So there's no reason to send anything before that. So a 206 partial content request, you can do a partial content request for a specific byte range. And again, this is useful when you're dealing with large files and you only want to send in the packet from a certain byte range to a certain byte range, and then over a period of time. So as you're buffering in that video, maybe you start at minute 1 and then you start buffering in the rest of the video. But so the partial content byte range is useful for those contexts where we're trying to send over the wire something very large, right? You don't want to just send a gig over the wire, but what you want to do is maybe send intervals of 10 megabytes maybe, or something along those lines. Okay, then we have the HTTP redirection codes. We have 301, which means it's been moved permanently. So the resource has a new permanent URL. We have a 302 found, which means the resource has been temporarily resides at a different URL. So the main difference between the 301 and 302 is one is permanent, one is temporary. And then the 304 is not modified. So the resource has not been modified since it's been last cached. And again, the important thing to note here is that let's say something gets back at 301 and it says it's been moved permanently, then our DNS can cache whatever we get back from, we're going to go ahead and then make that next round trip and ask for that new resource based on what the 301 returned to us, and then we can cache it, right? So the 304 tells us, hey, that resource that you got back, it hasn't changed since last time. And then what we can pretty much do at that point is just hit the cache and not have to make all those round trips. Now, let's go over the HTTP client error code. So the 400 is a bad request. So it's a malformed request. Let's say you're coming over here and then you want to use HTTP version 14. And let's say that doesn't exist. So it's going to tell us, hey, that's not something I recognize. So it's, so that's just, it's just not going to go through. Or let's say you're sending some information that the protocol doesn't understand, or you sent it in a weird way. So it's malformed. And it's just gonna spit back. It's like, the server doesn't recognize this, and here's a 400 error for you. So a 401 unauthorized. So this resource is protected, needs to be authorized. So again, this is not so much that you made a bad request, but you're trying to access something that at that point you didn't have access to. 403 forbidden. The resource is protected. So again, very similar to the unauthorized, except that the server says, hey, this is protected, so you're not getting access to it. It's not that it's necessarily you don't have authority. It's simply saying that they're just denying access to that resource with the 403 error. And then we get the 404 not found. So that means it's not so much a malformed request. It's just a request that resource you're trying to access, it's it doesn't exist. And again, we went over some of the attacks that can happen with this, but that's pretty much this is one of the ways that we can mitigate those attacks on the server side. If you see that you're getting a bunch of 404 requests from a certain IP, or from or that they're formed in a very similar way, and you keep getting back these 404s not found, then that might be a clue that you're being attacked. Because the requests are, someone's asking for stuff that is obviously not there, and they keep asking for it. So either you cut them off, or you figure out a way that you cut off that IP, and then at that point you can shield yourself from that specific attack. So let's go over the server error codes. And again, this is more of the codes that you will see once you're doing the development, and as you're developing something. These are some of the error codes that you might be getting. So you might get a 500 internal server error. So maybe they're like the server is not online, right? And then you make the request as a developer. I know this has happened to me, and you see on the terminal, it's like, well, that's you get a 500 back, and you're like, well, what the hell's going on? Well, maybe the server's not online, right? You get a 502 back gateway. So the server is a proxy, and the backend server is unreachable. So very similar, except that the server is going through a proxy, and then the backend server, it might be offline again, right? So then you might want to redirect the user back to another server proxy, or back to another server that's actually online. If 503 service unavailable, the server is overloaded or down for maintenance. Um, Again, this can happen if a DDoS attack is happening, or maybe you're just doing a simple maintenance, right? So these are some of the, if you see a 503 on the response of the request you made, then that's one of the things that can mean. And the other one that's pretty common is the 504 gateway timeout. So again, if someone asks for a very large file, and on your server you don't have a way, so let's say you don't have a socket connection open, right, or the connection times out, then it'll wait, like, I don't know, like 20 seconds, 30 seconds, whatever the server specifies. So if the server specifies that after 20 seconds, like, cut this off, right, like it's taking too long and we have other users to serve, so it'll just respond back with the 504, hey, that resource you're trying to get just took too long, and the server just wasn't able to get it in the allotted time. And then again, there are ways to get around this. One of them is that range request. So you're like, okay, well, you can set your server up so it doesn't send the whole gig over, right? So it doesn't load it into memory and then send it over. So the server you can set it up so it's set up in such a way that it's gonna send 10 megabyte files every time it gets it. So hey, as you get the 10 meg files, start sending it over. And what we're gonna do is we're going to reproduce that file. So we're going to just create that file piece by piece on the client side until we get the whole file, right? Until we send the whole 1 gig. But at least you don't get a timeout error, right? And at least you don't get a denial of service from the client's perspective. So you can still serve your users and send large files over the wire. So HTTP headers, right? So again, now that we know what actually happens when we make that request, right? When we type in a URL and we press enter, the first thing, okay, is the method, the getter, then the path, and then the version of the protocol. But then we have this other section here that are called the headers, okay? So the HTTP headers are very important in any request or response, right? They let the client and the server pass additional information with the HTTP request or response. So this is one way that we can have that stateful behavior that we're looking for. For example, we don't want a user to have to log in every time they visit our website. So maybe they log in once and then we send back a session ID, and with that session ID we can validate that they're the correct user, right? So that's one of the ways that the server and the client can send information back and forth, and we can keep some sort of state that's not included within the HTTP protocol itself, right? And they're essentially, the way they're set up, it's essentially a map of key value pairs, right? So you see the key over here, it's called host, and then the value of that, it's whatever you see on the right. So on the left side you get the key, accept language, and on the right side you see the value of that, which is in this case French, right? So and again, that's pretty much how they're set up. And again, one of the great things about headers is that they allow for experimental extensions to HTTP without requiring the protocol to change, right? So without us having to actually go through a committee, or the committee actually, coming to terms with something that they want to add to the spec, any client and any server can send or respond with any headers, and as long as they understand the headers, then HTTP kind of says, we don't really care. If you guys understand each other, then that's fine. So here are some useful HTTP request headers that you might come across. So the first one is host, so the domain of the server, right? And we saw that over here. So the host header, that's actually a one that's mandatory. The user agent. So depending if you're like searching from, let's say, Chrome or Firefox or Safari, that user agent will change, which is the name of your browser and operating system. Okay, and it's composed of those two things. So the refer, let's say you clicked on a link. So part of that request, when you click on one website and then go to another website because you clicked on a link, that request is actually going to have attached to it a referrer header, so that on the server side, if they want to track it, who's sending most of the traffic to them, that the referrer header, it's one of the ways that that's done. Also, the cookie header. So you saw in the curl example over here, you saw that we can set we said that over here we have the set cookie. So over here Twitter is setting a bunch of cookies that eventually are going to that they're using for either, let's say, ambient authorities, so to check if the user is signed in or not. So again, setting cookies is another very common header. And then the range header that we spoke about. So in that sense, what you're saying is, hey, I just want a specific subset. I don't want the whole file. I just want from byte X to byte Y, and just fetch that for me, please. So that's what that is. Another one is cache control. So you can specify if you want something to be cached or not. Let's say a resource that you send to the user doesn't really change, the same image or something. So maybe you're like, hey, cache this image, because they're going to be asking for a lot, and we don't necessarily want to, every time we serve it, it's going to be the same image. So once they have it, just cache it. So that way the client knows not to ask for it again. And once they cache it, then they can just get it from the cache instead of asking the server constantly what that same image or that same resource that's not necessarily going to change. So if modify sends, very similar. So only send resource if changed recently. So again, we saw that some of the headers that the server can send, it said, it hasn't changed. So if it sends that header, it's going to say, oh, okay, great. So like, just get it from the cache then, like we're just going to send you the header back without the resource, because we expect that you have the resource in the cache already. The connection, so you can actually control TCP sockets. So this is one of the ways that you can keep a connection open. And again, maybe you've seen like WebRTC or something like that. So they keep a constant connection open. And in this way, you can have VoIP, that functionality of like video and audio from two different computers over their wire, right? And then keep that connection open for as long as like the conference or the call is happening. So that's the connection request header. The accept header, which type of content we want. So if we send that accept header and we're saying, hey, we're expecting back HTML, and we get back like something else that's not HTML, then we can know it's like, like that's not what we were expecting, and then we can just discard that. Accept encoding. So let's say we accept like gzip, and we're sending back kind of a large file, maybe a React application that's pretty large. We can gzip it, and as long as the client accepts the encoding of gzip, then all is well, right? So you can create this encoding header. Another one is accept language. Again, as you can see, these are not standards, right? But they're common, and but all that's necessary is for that client and that server to understand these two things, and pretty much HTTP doesn't really care at that point, and they're like, fine, as long as both the client and the server understand each other, then they can allow you to attach any headers to any request, okay, and to any response for that matter. So yeah. Okay, now let's go over some useful HTTP response headers. Date, so when the response was sent. The last modified, when the content was last modified. So again, these are pretty much self-explanatory, but as you're debugging and as you get more into web security, these are some of the ones that you really are going to come across, and they're going to be helpful to help you debug or find out where there might be potential vulnerabilities. The cache control header, so it specifies whether we want to cache a response or not. And again, we're going to go over this in one of the attacks that I'm going to show you. The expires header, discard the response from the cache after this specific date. So you can just delete a cookie or something along the line. So you can do it through the expires header. The vary is a list of headers which affect the response used by a cache. So we're going to go over this in more detail as well. And then the set cookie header. So the actual response. So let's say you log into Twitter, and with that, and then let's say the login was successful. So then the server can actually set a cookie on the response that it wants. The next time the client makes another request to that same URL, it wants that cookie to be included, right? And then that was one of the ways that we were able to perform that not DNS hijacking, but cookie hijacking attack that you saw from the bank account, right? And then we were able, because the user had at some point logged in into that bank account, and then an attacker was able to get a user on another website, and then behind the scenes they were running a post request to the server. They actually made an action that the user or the client in that case was not intended to, but the attacker was still able to perform it because the header, the server at some point sent a cookie back that said, hey, whenever you perform a request back to the bank, just include this this header, this cookie, and we know that you have already been logged in. So again, if someone gets access to that information, you can see how it can become very, very dangerous. Or in your website, let's say you have some information behind some paywall. So only people that are paying customers should be able to access that information. And someone gets access to a session ID or something, and then they take on the identity of that user. At that point, there's really nothing the server will see different, because all the requests, any client can make the request, and as long as in the header they include their correct information, then the server has no way of knowing that this was a malicious request. And then at that point, that person is kind of a host. And again, in the banking example, it's a little bit more clear why this is dangerous, but it can happen in any case. And pretty much anyone can take once they have access to your cookies or that session ID. It becomes very, very difficult to defend against it. So some more useful HTTP response header is the location. So the URL to redirect the client to. So again, if we get a 301 response, usually with that response, you get a location response as well that tells you, it's been moved over here. And then at that point, the DNS resolver will make another round trip and then try to get that IP address for where that resource has been moved. The connection, again, on the server and the client. So sometimes the client wants to keep the TCP connection open, but the server's like, no way, we don't want to accept that. So the server can actually also control that. The content type, the type of content in response. So again, very similar. If the client was expecting HTML and the server can actually specify that. So if there's any mismatch in those things, then that can actually issue a one of the errors that we went over and say, this wasn't what we expected back. So yeah, the content encoding, the language, and the length. The content encoding on the server side, it's again, let's say the client says, hey, you can send, if you have a JSON, send it back in JSON form, let's say. And the server's like, oh, you know what? We do have it in JSON. We don't have to send the HTML back. And perfect. And so they send it back in JSON response. So there's a way for the client and the server to communicate over what the information is going to look like. The content language, again, this is just a header that you can use for internationalization. So again, one of the ways that you can do that, and then on the server side, that if you get the content language header, that the server knows how to respond to that. And then the content length is the length of the response in bytes. So usually with this, you can say, let's say you're expecting something that's a certain length, and no more than that, and then all of a sudden you get a file that's way bigger than expected, and then again that should raise some red flags as far as it's like, well, what's been included in this response that made the file so much bigger than it's supposed to be, right? And then again, it could be a code injection attack, or which we will cover later with XSS. But again, that's another thing that you can look at for the content length. If you're expecting a certain length and then you get something different, then it could be a red flag that something was injected that was not supposed to be there. Okay, so that's pretty much for HTTP, and that's the second part. So when we go on the web, remember, the first thing that happens is we go through our DNS. Then the DNS, the way it's sending all this information is through the HTTP protocol. That's pretty much the way that we're going to be accessing resources online. And then what we're going to do in the next session, we're going to cover some of the big vulnerabilities, and we're going to start with cookies, and then we're going to move into different attacks. Now we're getting to cookies, and this is where it's going to start getting a little bit more fun. We're going to start practicing some of the attacks and checking out some of the defenses. So now that we're over the DNS part and the HTTP kind of prerequisites to understand how all this works, now we can get into cookies. And to be honest with you, I don't really know how the web, how they, who sits in the standards committee and comes up with the name cookies. Who knows? Who passes it? Who knows? But cookies is what we got. And cookies are very interesting because cookies were actually, they were written in such a long time ago when the web was actually starting, and it's not at all what it is today. But they have become such a big part of the web that although we have a spec today, there are a lot of sites that use cookies in how they were first implemented, and it creates a lot of vulnerabilities. But again, they really are such a big part of the web that they're kind of used everywhere. As you can see, Netflix uses them, Google, pretty much everybody, right? And because we know that HTTP is stateless, cookies is one of those ways that we kind of keep state around, and we can create this idea of omnipresence, or and we're gonna go over what that means. But pretty much is a way to keep state from request to request without actually relying on the protocol itself, which by itself does not have a way to do that. So sessions. Let's go over sessions and what are sessions. So cookies are used by the server to implement pretty much sessions. Okay. So and a session again, depending on who's depending on your use case, let's just say a session can last as long as the browser is open, or maybe a session can last as long as until the user logs out, right? So there are different types of session, but the idea of a session is that some information is going to be remembered for a period of time past and over a period of requests, right? So it's more than one request, and some information is going to be remembered from one request to the other request, right? So that's pretty much what we want to think about when we're thinking of session. So the goal is that the server, they want to keep a set of data related to the user score in browsing sessions, right? So again, we see this in logins, in shopping carts. So let's say you add something to your shopping cart, and then you want to remember, hey, this user, maybe they clicked the back button, or maybe they removed something. So how do we remember that when a user, let's say, adds something to their shopping cart, then goes to the checkout page, but doesn't check out, and then goes back to browsing for more products? So where do we keep that information, right? Where do we keep the fact that the user already has some items in their cart, but haven't actually checked out yet? And what we want to do is we want that when they go from adding the item in their cart to even browsing more products, we want to keep adding those products to the cart, while at the same time, when they go to the checkout, we want to make sure all those products are there. But those are all different requests. So again, cookies are used to remember some of this information. And of course, ad networks use cookies to track users across different sessions. And we'll talk a little bit more about ad networks. I personally love ad networks. I think they get a lot of bad rep because of I don't know, bad actors in the network, but that always happens, right? Now the great thing about user tracking is it's the way that let's say, for example, when we go to Amazon can deliver a unique experience to each and every single one of us, right? And I think over time, if we do this correctly, user tracking, in my point of view, and again, anyone can have their own point of view, but I can just tell you the way I see things. And the way I see things is that because of user tracking, and because we were able to have our identity online, right, and track our behavior over time, services that really care about their users and about delivering better experiences, they can deliver those experiences really tailored to what the person wants. And over time, the experiences and the user experience can become such a wonderful thing, right? And they can deliver experiences that are far and above what can be delivered when there is no tracking available, right? So again, that's just my little side note on that. But again, user tracking uses cookies as well. So this whole concept that we're talking about here is called ambient authority. So ambient authority is to regulate who can view resources or take actions, right? And again, the idea is that who can do this through many requests, right? So as many requests are happening, so let's say you're going from in your Facebook profile, or some other profile, and you're clicking around, but at the same time you're staying logged in. The way that happens, or your Netflix account, your Amazon account, or wherever, as you're clicking around and you're staying logged in, that's because of this ambient authority that the server sent back the set cookie response in their headers, and they gave you a session ID, and because you have the session ID that kind of follows you on every request, then this is what ambient authority. This is what becomes ambient authority, and that's the way that the server can recognize who you are, and then at that in the same way can keep you logged in, right? So, but the idea is that they can ambient authority access control based on a global and persistent property of the requester. Okay, that's just pretty much the technical term for what we just described. And there are two main types of ambient authorities. One is cookies, and the other one's IP checking. Now, IP checking is used less often, but still good to know. For example, let's say you're logged into a university library site, right? Let's say you're a student and you're on the network. But the university, they don't necessarily want to keep, they don't necessarily want to know which student or anything, because once you're in the network, they can pretty much say, hey, you know what, they're on the network, they must be on the campus, so like let's allow them access to pretty much student resources, or whatever resources that they want to give them access to. Well, IP checking, it's something that's included with pretty much every request, and that's one way to keep track of, at least at a very high level, of where the requests are coming from. And let's say that they're not coming from the IPs that from the IP that belongs to the university or the library, then that request should not be allowed. But the main way to keep track is definitely cookies, and that's what we're going to be talking about more and more, and the attacks on cookies. So let's go over really quick. And I think for me, a lot of this stuff is interesting, so I wanted to include it for you as well, because I think the more we understand this, we kind of know why these things happen, and how it evolved over time to the state of how we are today, at least when I'm recording this video. So the history of cookies. Cookies were implemented in 1994, okay, in Netscape, and they were at first described in this 4-page draft paper. You can kind of think of it like someone writing on the back of a napkin, and that's kind of how someone got it. One of the browsers got it, I think Netscape, and then okay, cool, let's just implement that. And next thing you know, a week later, they were implemented. So cookies, this is all to say that cookies were implemented way before anybody was thinking about security, anybody was thinking about how the web was going to evolve, any of that. So cookies, bypass a lot of the modern day web securities standards that we have developed after that fact. But that's because they were implemented in 1994, and they were implemented in a half-baked way too, on top of that. So because the web has to be implemented in such a way that is backwards compatible, right? And again, everybody I think over here knows the awesomeness it is to make your website backwards compatible for every single browser, and the pain that it can cause when that's not possible. For example, let's not point any fingers, but Internet Explorer for a long time, it's gotten a lot more better now with Edge and all that, but for a long time, just to support Internet Explorer was a huge burden, because the standards that they had set up and the way that they implemented the standards was not the way other browsers were implementing the standards. So again, you might get your website looking one way when you access it from IE, and then if you were not an IE, you got it a completely different way. And again, this happened for a while until the standards kind of they I think they got the message, and they were like, guys, I think we have to abide by the standards, or at least get involved in this process of creating standards, so that the user can get the correct experience, and developers can code against this spec that we're creating for them, so that websites don't look just 50 different ways, and developers have to just develop in many different languages, or whatever. So that's kind of what's going on there. So cookies really didn't have a spec for 17 years, okay? Just pretty much until, I guess, recently, you can say. But for 17 years, since 1994, there was no official spec for cookies. And I'll include some of the links so you can read the specs if you're really interested in that. But I think they're incredibly interesting, and I think that they really are becoming better as far as the web security is concerned. But we're gonna go over some of the main pieces that cookies have, and that are part of the spec, so that you at least you know from a web security standpoint what you should be looking at and the things that you need to do to defend against some of the attacks that we're going to talk about. So let's talk about cookie attributes. So the expires header on the cookies, when we set cookies on the API that the cookie spec gave us, has this way that we can that we can specify when does it expire. So again, it pretty much says, you know, when do you want this thing to expire? You can expire after someone closes the browser. You can expire, you know, like 30 days from now. You can expire even 30 years from now if you decide, right? So a cookie can live on for a very, very long time, you know, or a very, very short time. But the expires part of the API allows us to specify this. Then we have the path. So the path, at least it tries to. It doesn't do it successfully, and we're going to cover that. But for example, what it tries to do is it tries to scope the cookie header to a particular request path or prefix. So let's say you are logged into to a website, right? And only when they access, only once they're logged in and they're on a specific path. So for example, the /docs path of the website, only then will the response header include a cookie. And if they're on any other path of the website, then don't include the cookies, right? So that's what the path attribute on the API tries to do, right? So again, this is one really, really weak way to for security to happen based on cookies. But you know, based on the path they are, you know, only certain cookies will be accessible. But we're going to see later on in XSS attacks and in cross-site scripting attacks that someone can, like for example, you can get framed into an iframe, and then someone can access cookies that are not part of that path through the iframe. Okay, even though they're not on the path. Okay, so again, this is not something that that actually works. Especially attackers know about this. So again, cookies, but the cookies do have this this attribute. And then the domain, allow the cookies to be scoped to a domain broader than the domain that returned the set cookie header. So you can say that let's say you're in a specific domain, but you can say, hey, you know, I allow this cookie to be scoped to pretty much like the whole domain range, right? So not just a path, but I want it to be scoped to the full domain, even though it's being set on a certain path. After it's set on the login page, any page after that, like just include the cookies, okay? So setting cookies. Let's see how we set that. So again, it's just the header. That's all it is. And all you have to do is to make the header, you just got to create the header. So the key of that is called set cookie. And then after that, the way you include the value of it, okay, is denoted by a semicolon. And then you can include as many values as you want within that set cookie header. So you can, you know, within the set cookie, you can call it theme equals dark. So that would be the name of the cookie. And then the expires and then issue a date or any of the other attributes that we talked about here. And we're going to look at that in more detail in just a few minutes. So again, how long can cookies last? Sites can set expires cookie to a very, you know, like very long, like 30 years. At some point, you know, some sites were setting cookies for a very, very long time. And some users, I guess, you know, you can say that they're like, you know, why do you need to remember my identity for so long? When I'm only logging in and then logging out, like it's not a site that I'm like necessarily like, you know, like if there's no use case, but they were still remembering a lot of information about these users. Again, that's just something that the server can specify. When expires is not specified, then what happens is that the cookie lasts for the current browser session. Okay, so that's the default behavior, and that's at least I wanted to get that across so you know that. So if you do not specify the expires attribute, then the cookie will last for as long as the session, that browser session. So if they close the browser, okay, so they have to actually close the browser, okay? If they do not close the browser and they just click away and to another, or not even click away, they go to another website, that session is still active, okay? So that's very important to understand. Like they have to close the browser, right? They have to terminate the process. Remember we talked about the process in the beginning? Like that process has to be terminated. If it's not terminated, the cookie is still active, okay? And then again, that's a vulnerability to cookie session hacking, okay? So that's remember that, okay? So how do you delete a cookie? Again, this kind of goes to how old cookies are. So you set the cookie with the same name and an expiration date in the past. That's how broken this API is, but again, that's what we have. That's what we have in the web. So you set cookie, then you set the key. the name of the cookie that you want, and then you put, for example, Thursday, the 1st of January in 1970 or whatever. You can just put at whatever time, someday in the past from where you are right now, and then that's how you delete cookies. It's completely horrendous, but yeah, that's what we got. So how do we access cookies from JS? So we saw that cookies get sent, okay, in the response header or in the client request, but the way we're going to perform these session attacks is that cookies can be accessed from JavaScript, okay, and then that's how an attacker can actually, if they again, even if you're in a different domain, but the attacker can make a post request to a server and a session is still active, then the attacker can actually include in that request the cookies of that person, and their whole identity pretty much, and then that server won't know that this was a malicious attack, and it pretty much doesn't even care where it originated from, and that's pretty scary, but it's the truth. Okay, that's just the way they are. So the way we access them, and we're gonna go over the code base, but the way we access cookies through JS is document.cookie, and then what you'll get back is whatever it is, name equals John, for example, and that's the way you can set cookies as well through JavaScript. So you can set it with an equal sign, and then you can set document.cookie favorite food equals cookies, and then the path. So every time so this is, I want to make sure I emphasize that this is not like a regular object. So in a regular object in JavaScript, when you go document.cookie and then you put this name value thing, and then you do it again, what the regular behavior that you should expect, if you know JavaScript, is that it'll override whatever we wrote before. But because the way cookies are, because of the way that cookies are implemented in the browser spec, the fact that the fact that we're doing document.cookie and then creating a value, okay, or assigning a value to it, and then down here in the next line we're assigning another value to it, does not replace this value, because they're different cookies, right? So they have different names, and because they have different names, the browser will actually treat it as different. It would just get tagged on to this object instead of being reassigned, right? So this is not this is not value reassignments or assignment. This is like literally the way cookies are set up. We are actually it's more akin to concatenating a cookie. Like that's pretty much what's going on. So the next time you go document.cookie, if you were expecting favorite food equals cookies to be what you got back from that object, you'll be mistaken, because what you're gonna get back is both those values that we set, the name John and then the favorite cookies, as your cookies that are set for that session. Okay, so just again remember that. So yeah, so document the cookie and then the name. So let's say we're got name with so again the key of the cookie that you want to delete. So like this is how we delete cookies. So you go document.cookies equals then the key of the cookie you want to delete, and then a date in the past. And then once you pass along, and then you call document.cookie again, at that point you would have deleted the document.cookie name John, and all you got back is just the favorite food cookies. So that's so yeah, if you were thinking that this is value reassignment, it's not. Okay, you actually have to go ahead and actually delete the cookie yourself this way in order for the cookie to clear itself. So yeah, now sending cookies over unencrypted HTTP is a very bad idea. Okay, and again, most websites nowadays, if you get a TLS certificate or something, then most of the communication is encrypted. But anybody, let's say that someone is performing a man-in-the-middle attack, which is something we cover in the DNS section of this course. If anyone sees that cookie and they're snooping, they can use it to hijack the user session. Okay, so if you're sending these cookies along kind of as raw text, as we saw in the request header without any encryption, then anybody can pretty much that's one way an attacker can assume identity over the victim and then perform any sort of attack at that point, right? So the attacker sends the victim's cookie as if it was their own, right? And that's how we were able to perform the bank attack, okay? And then at that point, the server will be fooled because the server doesn't actually see any difference from their point of view. The client made a request; it was a valid request. to a valid resource, and all the right cookies were sent, right? This is because the attacker got access to those cookies. Um, so yeah, the server at this point will get fooled, and that's one of the attacks that we're going to cover now. So let's just go over it in theory, and then we're gonna go see how this attacker is done. So let's see over here. So the attacker ingests a script. So the attacker somehow gets the user gets either the user to click on a link that they own, right? So to one of their websites. Then the victim authenticates the server, right? So they have some type of session live, right? So active. They have some type of session active to another website, right? So then the server returns the page code with the injected script, okay? And then at that point, the victim's browser executes the script and sends a session cookie to the attacker. And that's the attack that we're going to go over, the bank attack. I'm going to go over in detail how that happened. But again, you were able to see how, although we were logged in into a different website, the fact that we had logged in into that previously to the bank and our session was still active, then and then we went to a malicious attack, to a malicious site that had a script that was running. Then the server was able to perform that attack without necessarily the victim being aware of it, right? So let's before we get into that, let's go over some of the things that we can do to secure this, and then we're gonna go and actually implement the code. So session hijacking mitigation. Use secure cookie attribute. So there's this attribute in the cookie API that if you use it, prevent cookie from being sent over unencrypted HTTP connections. Okay, so if someone tries to get a cookie through HTTP instead of HTTPS, then that way. So for example, at first, especially when submitting a form or something like that, if this is not set, then the cookie will be sent unencrypted, right? And then anyone pretty much can see the cookie, and then they can steal it at that point, and then do whatever they want to do, right? So that's a no-no. Okay. Another thing that you can do is session hijacking mitigation. It's use the HTTP only cookie attribute to prevent cookies from being read from JavaScript. So if the cookie HTTP only attribute is set, then all these things that the way we were accessing cookies from JavaScript, then at least that's it's you won't be able to do that. So that's another way to mitigate against this attack. And then at that point, then the server, at least the attacker can't, although it will be sending the request, and you will see it from the response and the request, it won't be accessible through JavaScript, okay? And then that's one way to mitigate that. Okay, so let's talk about how we can bypass the cookie path attribute that we talked about. So again, like I said, don't use this for security. It doesn't work, and we're going to cover we're going to cover an attack to show you how we can bypass it. But again, it should not be used for security. The path does not protect against unauthorized reading of the cookie from a different path on the same origin, and this is the main attack vector. So if someone's on the same origin as you, so if it's a subdomain or something like that, then someone can iframe it and essentially hijack the cookie as well. So again, it can be bypassed with an iframe. Then that iframe can be read with read.iframe.contentDocument.cookie. So iframe.contentDocument allows us to read the iframe's document as if it was our own document. We're going to cover that in just a few minutes. But yeah, so that's not if I think a lot of people used it in the past for and they have the misconception that this would allow for this to work as a security feature because it's set on a certain path. It's not. You can bypass it, and again, it should not be used for security reasons. So again, as long as it's the same origin policy, that's pretty much and an iframe can achieve this. So therefore, only use path as a performance optimization. Again, maybe you want to set the theme of a certain sub resource or like a certain URL to maybe a dark or light mode or whatever. Something something that has to do nothing with security, and again as an optimization rather than as a security feature. So yeah, our cookie path secure? No, there is no solution against this attack. So if you're using this cookie path and you thought that this was secure, again, there is no solution. There is no way to make this secure, so it's always unsafe to use. Okay. So again, so now let's talk a little bit about what is the main problem, right? So we know that we have that we want a request to have this ambient authority, right? Because we want to keep some type of state across different requests. But the problem is that it's unclear. Once we have ambient authority, right, through cookies, then it becomes unclear for the server to know which site initiated a request, right? So consider this HTML embedded on attacker.com, for example, right? And then the browser hopefully includes bank.example.com cookies in all requests. And that's the attack I showed at the beginning, where a person had logged into their bank account, but then they, through either a link or somehow an attacker was able to get them to run a piece of JavaScript code on their behalf and submit a form. Then they were able to create a bank transfer in on behalf of that user, and we will cover that that attack in a second in detail. I'll show you the code for that. Also, yeah, so that was a cross-site request forgery, CSRF for short. So the attack which forces an end user to execute unwanted actions on a web app in which they're currently authenticated, right? So if you're authenticated on a different website, and someone and then you navigate to a different website, but you're still authenticated on that website, if someone performs a post request, then those cookies will get sent. Unless again you mitigate against that. I'm going to show you right now how to mitigate against that. So normal users, CSRF attacks can force the user to perform requests like transferring funds, changing an email address. So again, if you're logged into maybe Gmail or even WordPress, for example, then this can be this can be a lot worse, because once an attacker has access to your identity, if they log into, for example, as an admin credentials, and then they log into some WordPress website, then they can they can do SQL injections or attacks that have a different level of security access that are way more dangerous than a simple attack. For admin users, again, it can force admins to add new admin users on a database, for example, or in the worst case, to run commands directly on the server, right? So you can run like shell scripts even. And again, this if an attacker has this level of access at this point, you're pretty much hosed, yeah, you're kind of screwed. Okay, so like, don't let it get there. But it's this is with the CSRF method, it's possible to scale the access of an attack. So effective even when attackers can read the HTTP response, as we saw, because the way the browsers works and the way cookies work and the way requests work, they get sent the cookie anyways, as long as the user has been authenticated, right? So, and this is that concept of ambient authority, and these are some of the issues with it. So what are we left with, right? So what's the idea? Can we remove ambient authority when a request originates from a different website? So is that possible? Yes, it is. We're going to cover how to use that. And the way it's done is through another property that cookies have called same site cookies. So this came in the spec afterwards. So after a lot of these attacks were being out in the wild, and they were happening more and more often, and they we were able to see the escalation of attacks happening. Then the spec changed, and we created a new property on the cookies API spec that's called same site. So the same site cookie attribute is to prevent a cookie from being sent with the request initiated by other sites. So again, that attack that we showed of another user being authenticated, and then even though they're in a different domain, those same cookies by way that the request is that the user is still authenticated, the session still active, then those requests would actually still go on, right? So, and then there's three levels, or three properties that three values that you can set on that property. The first one's none. So this is the default one actually, which essentially says SemSite equals none. This is the default behavior, and essentially what it says is always send the cookies, right? So this is what we saw. So unless you actively defend against it, there is no defense, right? So because the browsers by default have it set to none. Now that the next level is SemSite lax. I know it sounds like lax, like it's pretty relaxed. It's a lot better than none. What it does is, and this is probably a good default to have. Again, it depends, how you're looking at things and the filter you're looking at it through, the perspective. But I think none is fine. I think it should be on it should be on the developer the burden to like protect this type of stuff, because again, for tracking purposes and backwards compatibility, I do believe that same site none is the correct use, and only if you're a pen tester, or again, if you're a developer, then these things become relevant. But I do not think that users should have to worry about that. And again, because of, I think the more customizable the web becomes, I think we can create much better user experiences. And for that reason, but again, if it's an issue of CSRF, then maybe lax is the correct thing, because you would only want that experience to originate and then happen on the same domain or the same origin. But we can think of other experiences which are cross-domain, right? And if we're not just thinking of domains, but if we're thinking of the web as a full-fledged applications where different sites are pulling from different resources that can originate or they can be hosted on different origins, then I'm of the belief that with better tracking, and tracking maybe is a bad word, but the fact that we track user behavior across different websites, it simply means that we could create much better experiences that are customized to each individual user once the technology is there, right? So, but anyways, I think that's an opinion that we should all come to our own conclusions on that. But Lax kind of does that, right? So Lax withhold the cookies on the sub resources requests originating from other sites and allows them on top level requests. So if you're in the same origin domain, it allows it, and if you're in another domain, then it doesn't. And then there's this kind of same site equals strict, which is the most aggressive setting you can set, which only sends cookie if the request originates from the website that set the cookie, right? So that's like even subdomains on the same domain won't work on this, right? So same site strict is, I think it's pretty aggressive, but again, it's there. And unless you're like a bank or you have some very sensitive information, maybe this is what you want to set. But other than that, there's probably not what you want to set, because if you do set it to strict, like let's say if you've seen any embedded maybe Facebook comments embedded on different sites, and then people can leave comments, but the comment box actually knows that you're still logged into Facebook, so it comes from you yourself, your account, right? That's a behavior that we kind of like on the web, right? And that's only possible because of the cookie session that you have from your Facebook account. But if it was set to strict, if that cookie was set to strict, then that wouldn't be possible, because that code that's embedded on a different website, which is again the behavior that use case expects, would not work for this, right? So again, very aggressive. I think Lax is probably the best security wise. That's probably the best for cookies that are sensitive. And again, the way you set it is on once you set the cookie, you put secure HTTP only. The path, always set it to home, because like we said, that should not be used as a security feature. And then you put as the last feature, same site equals Lax or none. Again, remember, none, you don't have to set it because that's the default. So that's kind of what it comes with when you don't set anything, or strict, right? So you can put none, lax, or strict, and then that's kind of what you have. So yeah, so the way to mitigate cross-site request forgery, it's and we're gonna cover it in the code. So we're gonna run over the same attack, and then we're going to try to protect against it, defend against it, with what we've learned so far. Okay, so before we get into that, and I show you how to defend against the attack, some final thoughts on cookies. Cookies are used to implement sessions. Okay, remember HTTP is not a stateful protocol; it's a stateless protocol. So we use cookies to have this ambient authority and implement the concept or the idea of sessions across different requests. Remember, the server can never trust data from the client. It's not that the client is untrustworthy. It's more on the way that the web is created, which any request can come from any client, right? So it's a very flexible system, that the way the web is created, and because it's so flexible, it also makes it kind of in some ways also very vulnerable to attacks, because it has to it has to serve and accommodate all these different clients that might be requesting different resources, and it's not something that the server can necessarily control. So ambient authority is useful, but opens us up to additional risks. And if you remember one thing, say your cookies like this, secure, HTTP only, the path, same site lax, and then expire maybe like 30 days, right, from when it's set. Again, you can always set the cookie again. So this is probably the best defense, especially when dealing with cookies. And now let's go over the same attack that we showed at the beginning, and let's see how we can defend against it. Let's go over the attack one more time so we can remember. So remember, this person logged into their account, okay? And let me show you the server code really quick for the victim. So we have pretty much a table called users and balances. We gave Alice 500 and we gave Bob 100, and we can see their passwords. So the first things, and then we just created a simple express server. The first route we get, it's is the home route. So what we're doing is we're getting the session ID from the cookies. So if the user already has a session ID, we're gonna get it from the cookie, and it's called the session ID. And then what we're gonna do is we're going to see if that session ID matches any of the sessions that we have over here. And then what we can do is it's a mapping pretty much from the user to the session ID, and then that way we know that their username and their password was correct. So if username, okay, so if we do find that their sessions matches their session ID, then we set their balances for that username. So we get the balance for that username, and then we render out their profile at that point. If we don't have that, then we have the index page where they can log in. Then we have the login page, which again tries to get the username from the rec.body. So at this point, we're going to be sending the username through the login form. Okay, so remember, that's the login form. Then the password will become the users, and then through the username, then we get it from that table. So if the password, okay, that we get from the table matches the password that they entered, what we're going to do is and this is, so again, this is the first way to defend against the session hacking attack. What you want to do is you want to create a session ID that's random enough, right? That every single user that you can compare it essentially against something that's on the server. But at the same time, if someone were to get that session ID without any context, then it's not something that they can use against the user, right? So for that, what we use is we're going to use the random bytes function. That's part of JavaScript, and we're going to base64 encode it, and then that's going to become the next session ID, which is, again, that's just going to become the user session ID. So we're going to set the session ID, and at this point I'm going to show you without the secure true, the HTTP only, and the same site lax. So I'm going to comment this stuff out just so we can see how the attack was performed, and then we're going to go ahead and we're going to do it again, but I'll change it at that point so that we can defend against it, okay? And then all that happens in the logout path. It's, again, we're going to get the session ID from the cookies, because if they're logged in, then we know they had a session ID. And then we're going to go ahead, delete session ID from our table, and then we're going to clear that cookie called session ID, and then we're going to redirect the user back to the homepage. And then the transfer route. So the transfer route is the following. So we have the session ID, which again we're going to get from the cookies, okay. And then what we're going to do is pretty much the same thing we did for the homepage. So we're going to get the username from the sessions table and passing it in that session ID. If it turns out that there is no user name, then we're going to send a fail. So it's like, hey, you know what, that's not allowed. So again, that's if they don't have, if they've logged out and then the attacker tries to send a post request, but at that point, then that user has logged out already, so the session is not active. Then we know that they shouldn't be able to transfer any funds if they don't have a session active. Okay, if they do have a session active, then what we're gonna do is we're gonna get the amount from the body that they want to transfer, and then we're gonna send we're gonna get the to also from the body to who they want to send it to, and then what we're gonna do is we're gonna deduct from the balances table and that username the amount, and then we're gonna add from the balances table to the to user the correct amount. So essentially that's what we're gonna do, and then we're gonna redirect them back to the homepage. So that's pretty much the victim server. pretty simple express server. On the attacker server, what we're doing is we just have the homepage and then the attacker transfer form. That's so the reason I created the attacker transfer form, and I'll show you the HTML for this right now, is so that we can include it in an iframe. And the reason for the iframe is that once we perform a post request on the form, usually what happens is that we get redirected. So because we don't want the user to actually notice that anything it's happening, because we want to hide the attack. So if we put it in an iframe, then that's one way that that we can bypass that redirection, at least on from the perspective of the client, right, of the victim. And then for the app get for the homepage, then what we're rendering is essentially any random page, and all we have in this page. So I'm gonna go over here, and then on the attacker page, all we have is the iframe. Okay, so that's all there is. But let me just go ahead and let's put in an H1 here, and then attacker site, just so it's really clear where we are. And yeah, that's pretty much it. And then the index file, you guys saw that. It's a pretty simple page, just with a login form. And then the profile page, again, shows the balance, and then has a form to make the transfer. And that's pretty much it all. Yeah. So let me show you the attacker transfer form. So the attacker transfer form, it's a post request on the attacker's website. So remember, this can be embedded into any website at all, right? There is, like I said, the way HTTP is set up, it doesn't stop us from making any post or get requests to any other HTTP client. Okay, so at that point, we're going to actually perform a post request to the local host, which is the victim's computer in this case, and then the transfer path. And then at that point, we're gonna just enter the amount that we want to transfer. So I think if we put here, so let me just do this. Yeah. So let's go ahead and run the attack again, so we can see it in action. And I'm gonna go ahead and restart the servers so that we know that so we can see it working from the beginning to the end. Okay. So then I'm gonna go ahead and start the victim server up. I'm gonna start the attacker server on a different port, and then I'm actually going to start a I'm gonna use ngrok in so that we can actually be on a different domain completely, so that we can see the full effect of the attack. So I'm gonna refresh here, and then all our cookies, the cookie's still here from the previous example, but then at this point this cookie is invalidated. Okay, because remember, once a new session started, then that cookie will be deleted. So I'm just gonna go ahead and delete it over here. Okay, so let's go ahead and go to the network tab. Okay, and I'm gonna clear this stuff out, and then yeah, so I'm gonna log in, okay, as Alice, and then password, and then let's go ahead and see what got sent on the through the form. So as you can see, this was not encrypted, right? So anyone in looking at this request can see the username and the password sent. Okay, so that's one vulnerability. Then the other one, we see that in the response, we got a we got a new session given to us. Okay, so now that we have that, let's go over to the attacker site, and then let's open up the network tab as well, and then let's go ahead and transfer some funds. So we're going to transfer, in this case, $100 to Bob, and then let's go ahead and click transfer. So we get the transfer. We get the transfer request over here. So that's a request that this attacker website created. And then let's see what's included in the request headers. We can see that in the request headers we have the session ID, right? And if we compare the ID to the cookie session ID that we have for that user right now, it's the same session ID, right? And although it's originating from a completely different site, okay, so this one's actually coming from a completely different domain, right? So different origin, all completely, right? So that's a request to localhost 4000, but we can see that the referrer is actually localhost 5000, right? So that's a completely different website issuing on the user's behalf on a request. And one of the things I want to try out is I want to show you how you can actually do this through JavaScript, so that you don't even have to fill out the form, and you can automate the whole process, or an attacker can automate a whole process themselves. Okay, So what we're gonna go ahead and do, I'm gonna go ahead and write a little script, okay, and then let me show you that in a second. Okay, so I'm gonna go ahead and add a little script to the attacker transfer form, and I'm gonna go ahead and what we're gonna write is we're gonna write document.forms. So in this case, we know we only have one form, but if you have access to the form, or if the attacker gets access to the form, then through JavaScript they can give it an ID and then target that form. And then what we're gonna do is we're gonna submit on the behalf of that user. We're gonna click the submit button. I also added a value 100, and we added the amount to Bob. And then what we want to do is we're going to come to the attacker. Let's see, the attacker EJS, and then I'm going to put display, and I'm going to call it none. So this way, although we're still going to be on the attacker site, what we want to do is we want to see what would happen if the attacker was running this, just so you can see how hard it is to spot from the perspective of the victim. So I'm going to refresh the page. Now we don't have access to now. If this was a completely different, website that the user is on, then they would have no idea that we have an iframe form that's making a post request to a site that they can potentially have a cookie session still active, right? But if we do go to Atlas's account and then we refresh our account, we see that the current balance is 100. And I'm gonna go ahead and refresh this again. And then if we go back to Atlas, so again, at this point you see nothing happening right on this side, other than, so the user will be completely oblivious that a post request is being made. But if we go back to their account, we can see that their balance actually goes back to it's actually decrementing, right? So their account is definitely being affected, but they would have no idea from looking at this site that that's actually happening, right? And that's how it could be done with JavaScript and a simple JavaScript injection, and that's a cross-site request 4G attack by using the session hacking attack. So now I'm going to go ahead and we're going to go ahead and so stop the servers. Okay, then what we want to do is I'm going to go to the victim server, and now we're going to apply the our to our cookies if our defense. So, and then we're going to see if that attack still works. So now to our cookie, what we're going to do is secure true. Okay, on the login path, we're going to do the same thing. So once they log in, what we're going to do is we're going to issue the cookie. We're going to put secure true. That way it's over HTTP every time and it's not unencrypted. We're going to put a HTTP only as well, so it's not accessible to JavaScript. We're going to set same site lax, instead of none. And then we're going to set the max age for 30 days. And then again, that's pretty much it. And then we have the logout path and then the transfer path. So for that, let's see here. Do we need to change anything? No, I think we're good. So I'm going to go ahead and save this file. And let's go ahead and start up the servers. So the servers, again, victim server, we're going to go ahead and start the attacker server. And then we're going to go ahead and actually start ngrok on port 5000. That way we're on a different domain. I'm going to go ahead and reload this. So again, we should see that we're logged out. If I go to let's go to the application tab, and let me just delete this previous cookie, although it's not valid anymore. Let's just delete it so we're working with a clean slate. All right, so we're logged in, and I'll look into what the secure. The reason why secure true is not going to work right now is because we're over HTTP instead of HTTPS, because we're on the local host. So again, that's so I'll comment it out for now. But as you can see, it's it didn't even let the cookie go through because we weren't on HTTP. So at least we know that's working. Okay, so now we have a session ID. Perfect. Now let's go and go to our other domain. I'm gonna exit out of here. So now we're on the attacker side. And if you remember, we have the div and all that hidden. But let's see. Okay, let me see the. Let's go ahead and see the if anything got deducted. So nothing got deducted from this account, right? And I'm gonna go ahead and refresh it, and let's go ahead and go to the network tab, okay? And let's see what requests are sent. So now we sent a request to the transfer to the attacker transfer form, right? And then to the transfer path on the other domain, right? So on the 4000 domain, we're sending a request to it. And let's see what the request headers have. So they refer let's see if we see anything for the cookie. So the refer is that we have no cache. We see that there are no cookies being sent anywhere. And yes, sec fetch. So same site. So same site is since it's telling us, since this is not from since same site, we're not going to actually include the cookie anymore. And as you can see, even if we refresh this multiple times, right, we can see that we go back to the bank website, and then nothing has this attack has not been successful anymore. Okay, so there you go. That's how we that's what session hacking is. That's how we defend against it. And as well, we went over DNS, HTTP, and then we're getting a much clearer view of how we can go in and with just a few simple defensive mechanisms really stop attacks that can cause a lot of vulnerabilities in our systems and our applications, and protect our users in that case. Okay, so anyways, hope you enjoyed it. And then we're gonna move on to different attacks now, XSS and iframe attacks, and then we're gonna move over to the server side attacks and then in injections. Okay, now in this part of the course, what we want to cover is same origin policy, and this is important to understand because this is fundamentally the security model that the web has implemented. And once we understand this, we'll be able to understand how is it that we can fetch different resources, not just from our own domain, but we will also understand how other domains can fetch information from our own domain. So resources that are not in the same URL or domain, they can be accessed or not accessed. So we're going to talk about some of the attacks and some of the defenses, and just so you can get an idea of some of the stuff that could happen once we understand some of the attacks that we're going to cover in this section. Let's just imagine that this is a login form, right? And over here, what I've done is I've gone ahead and implemented an iframe. So imagine that this iframe, so that some site you've iframed, and then an attacker, what they've done is that they've taken you maybe to a website that looks just like the bank website that you used to log into, right? And then you have the login screen and all that. But essentially, what they've done is they've iframed your bank a website into their own website, and then essentially you couldn't tell the difference. Okay, now right here, what I'm doing is I'm showing that there are, just so you can tell that the iframe is hosted on localhost port 5000, and then the login form, for lack of a better term, is hosted on port 4000, right? So we're trying to emulate here the fact that these two sites are completely different websites. And what I'm going to do is I'm going to type on this login form, and you can see how an attacker can access the iframe, and then based on what the login, based on the input on this field, it will show up. It will be reflected on this iframe over here. So let me just type username. And then, as you can see, the attacker could be getting this information as we type it in. So again, this is something that's that could be very dangerous, and we're going to talk about some of the attacks to mitigate against this. For example, I'll show you really quick how we can actually decide that our site, we never want it to be able to be iframed. So before we talked about a defense that how we can defend based on cookies and same site origin. So setting that as a header was one of the ways that we can mitigate against the attacks that are session hacking attacks. But another type of attack, which is cross-site scripting, which involves requesting resources that do not belong to the same origin, and then accessing those, so crossing this boundary over here from one resource to the next, and then not just communicating, but controlling this resource and making it do what the attacker wants. And again, we saw an example here that this could be analogous to someone even, not just hijacking a session, but essentially really getting your credentials for any website that you might be logging into or a user of. Okay, so let's get into the same origin policy, what it is, and how does it work in the web essentially to create the web security model. So let's think about when we're in the web, okay, and we're talking about web security. Let's think about what should be allowed, right? So when we're thinking normally, okay, as we're navigating websites and things like that, let's go over a few scenarios and let's see if intuitive we can say, hey, you know what? I think this is something that should be allowed in the web or it shouldn't be allowed in the web, right? So let's go through the first one. Should site A be able to link to site B? Well, yeah, I would say yes, because this is the main way that the web works, right? The web, it's made up of documents, and those documents have links that link to other resources, right? So again, I don't think there's anything wrong with this, and this is essentially the way the whole web works, right? So the reason why it's actually called the web is because it's this interconnected link structures that connect to any other resource, right? So pretty much anything on the web can be a link and can access and can link to any other place on the web itself, right? So second thing, should site A be able to embed site B? Again, maybe there's good reasons for why someone might want to embed something on their site that doesn't belong to them. So if you think of YouTube, for example, you can embed a YouTube video on any website, right? So they give you an embed video, and that's actually a very or any other video hosting website that maybe you host it on their service, but then you want to show it within your own website context. Again, totally valid reason for having this functionality be part of the web. Another scenario, which is, should site A be able to embed site B and modify its contents, right? So this is kind of what we were just looking at in the previous example, where not just did we embed a website within another website, so not just did we embed one frame within another frame, we were also able to change the contents of it. So whenever someone types something in one, it kind of reflected on the other one immediately, right? So that's that again, that kind of gets us in like hot water, because that, there could be some reason why, like, that's definitely a vector which someone can attack. But again, there could be totally you know valid reasons for having that functionality be available. For example, if we wanted to create an API in real time, and we wanted to reflect to anyone who subscribed to that endpoint the changes as they happen in real time, right? That's completely valid, and we see that all the time with real time services. So again, it's just something that we have to know and think about. The next one, should site A be able to submit a form to site B? Again, we've seen this in the past in previous lessons, that whether it should or not, it's definitely possible, right? So we definitely know that this is part of from the beginning of the web. This was implemented, and we saw how we can kind of attack this by with session cookies, and session hijacking can actually happen because of this feature. But again, it's been part of the web since the beginning, and I don't think it's going anywhere. So yeah, this is something that happens all the time. And again, there are completely valid reasons why someone might want to automate a certain process on the client side, and for that to happen, we're gonna submit a form on the user's behalf. So again, there's completely different valid reasons for this functionality to also exist on the web. The next one, should site A be able to embed images from site B? Yeah, absolutely, right? We can actually, let's say that we want to host our images on a CDN. That way they can be cached, and then we don't have to use up our own bandwidth, but we can still serve our own images. And that happens all the time for big websites that have a lot of traffic, and we want to make it as efficient as possible and optimize that bandwidth. So again, embedding images, and even the next one, which is embedding scripts. If you've ever embedded jQuery or any other scripts into your own websites as you're developing, this is again just part of how the web works. And as far as we're concerned, we I don't think it's going anywhere, because it's again, it's fundamental to how we build websites. And as the web becomes more and more powerful, I think this is just something that's going to become even more of a prominent feature, and something that we can really be more useful. So again, I don't think this is going anywhere, but again, this is again part of the stuff that we have to be thinking about when we're thinking about same origin policy, right? Because these are all parts of the web where we're accessing resources that are not necessarily part of our own domain, but that we need in order to serve our users' endpoint. But again, Because of this, you can kind of see how all these things kind of open us up to certain risk and vulnerabilities on the client side. So when we're talking about same origin policy, if you remember one thing, remember this. This is the fundamental security model of the web, right? And it goes something like this, right? So this is kind of how the spec is laid out. Two pages from different sources should not be allowed to interfere with each other. Okay, so if two pages are in different domains, then essentially someone should not be allowed to mess with one other domain. But again, we have seen how with iframes or with cookies and things like that, we can get around some of this stuff. But this is the essential security policy that the web is trying to enforce when they created the spec, essentially. So if we think of the web as an operating system, it really will help us out in understanding how some of these security features and came to be, and then some of the stuff that we can do to mitigate it. So what is an origin? That's the first thing we need to understand. So an origin, if we're thinking of the web as an operating system, it's very analogous to an OS process. So when you open up an application on your computer, right, that spins up a new process on your computer. And the web, in many ways, whenever you spin up a new tab or a new website, that's kind of like a new process. And again, on the web, it's called task. And we went over this in some of the first lessons. But it's very similar to a process on the computer itself. The web browser, you can think of it as analogous to an OS kernel, right? So this is where pretty much we are going to load and have access to APIs that are part of the browser or to the web itself, right? Or to the origin, right? So if you are on, let's say you open up iTunes or any music player on your computer, then that has access to the files where your music is stored, right? Or if you're opening up some other application on your computer, then that has access to the memory allocation on your device, right? So again, the web browser is pretty analogous to this. Once we open one up, it's analogous to the kernel, and through the kernel, we can we have access to different APIs and different services of the web itself, right? So sites rely on the web browsers to enforce all these systems and security rules, right? So we're just like the kernel, and how a computer, when if some malware gets installed on your kernel, then that's that kind of screws everything up, because then your computer is compromised. It's the same thing on the browser, because we are relying on the browser in this case to act as the operating system and to enforce the security rules that the web that the spec is supposed to enforce, right? But again, the browser at the beginning was not intended to be this way, but it has evolved to this to kind of this powerful application that everyone uses. And as we're trying to move applications more away from certain marketplaces to be broader accessible, then we turn to the web, and the web again wasn't made for this thing. So just like in OS, if there's a bug in the browser itself, then there are these rules that go out the window, right? So we're going to go over the rules that are the same origin rules. But again, if there's an issue with the browser, or the browser gets compromised, right, or someone's able to execute some code on the web, on the browser, then kind of these rules go out the window. So what's the basic rule? Again, the basic rule is this: given two separate JavaScript executions, right? So two different tabs, two different domains. One should be able to access the other only if the protocols, the host names, and the port numbers associated with their host documents match exactly, right? So, and this protocol host port tuple is called an origin. So let me just show you an example of what we mean by this. This right here, right? The protocol, the host, and the port. So this whole thing, and mostly what we see on the web are these part. We usually don't see the port number, although it's there implicitly. For most websites, it's port 80. Once we have this thing, this is kind of only so if this website is trying to access some other resource, what needs to match in order for that resource to go through, or for that request to go through and not get blocked by CORS or by the same origin policy, then the HTTPS, right? So if you're making a request from HTTPS and you're requesting something over HTTP, then that's going to get blocked. If it's trying to access something from a different website, so a different domain essentially, host, then that's going to get blocked. And if it's on a different port as well, then that's going to get blocked. So all these things have to match for all those requests to go through, right? If you're trying to make a request from within JavaScript. And just to show that this is not very hard to, if we wanted to create our own function that checked if we just like the same origin policy. So if we wanted to execute this ourselves and actually create our own function, it's not really that difficult, right? All we have to check is the URL protocol, right? The host name and then the port. And if all those things do match, then what we say is, yeah, this website's allowed to request a resource from the resource they're trying to request, then it's allowed, and we should return it at that point, right? So we should return a response code of 200, and everything is fine. If one of these things do not match, then we know that we have an issue, and then someone else is trying to access a resource. So this could be something that's behind a paywall or behind some type of authentication, and then that way we know that then they should not have access to this resource, right? Okay, now let's go over the attack that we saw at the beginning of the lesson, and let's see how we implemented that attack, right? So the idea is, can we send messages from a parent page to a child iframe or vice versa, right? So we need a way to get around the same origin policy to allow two different origins to communicate. Now that we know that the same origin policy is not going to allow us to do this, we need a way, because again, there are very valid reasons for why we might want to communicate. Again, and one that comes to mind automatically for I think all of us will be an API, right? How do we access an API that's on a different origin and communicate with that API if we need some data or some resource that's not necessarily something that we have ourselves, right? So this could be weather data and you're trying to access the weather API or anything like that, right? So first we're going to talk about how we're going to execute this attack, right? So what are the vulnerabilities in this, and then we're going to go ahead and talk about some of the defenses for this thing. So the way the attack was executed is actually very simple. Okay, so I'm just going to show you the child code. So I'm going to set up again two servers to kind of showcase these are two different, okay? Remember, two different origins, and the origins are the protocol, the host, and the port, okay? So I'm gonna, one of them, the child is gonna be on port 5000, and then the parent is gonna be on port 4000, okay? So the first thing we're gonna do is we're gonna do this. On the child side, okay, which is the page that's going to be iframed, right? So this is gonna be kind of the page that's gonna get attacked. We're gonna get, we created a div, then we got a handle to that div, and then we're going to set an interval, and that interval, what it's going to do is it's going to accept through this window hash, and for a long time this is the way that we were able to get around the origin communication. So what we did is, if you remember when I talked at the beginning about the way URLs are formed, we can add to the URL at the end a little hash, and that actually does not refresh the page. What it does is it's kind of like an anchor tag, and it takes you to that page on the tag. So what we can do is we can use that part of the URL as a communication mechanism. And then what we're going to do on the parent side, it's we're going to create an input, right? So we have an input over here, okay? So we're going to get a handle to that, and then we're also going to get a handle to the iframe. So we're going to iframe that child page in here, okay? And remember, that's hosted on port 5000. So now that we have access to the input and the iframe, now that we have a handle to those, over here what we're going to do is we're going to add an event listener. And anytime something changes in the input, what we want to do is we want to change that iframe source. So remember, we can change also on because we're embedding this iframe, then we can change the source of it, which again, this is why the attack works and how we can get across cross origin, across the origin domain policy that we shouldn't be able to do because these two pages are actually on different origins. But anyways, this is what we're gonna do. So we're going to include the regular URL. So up to this point, everything is the same. But then what we're gonna do is we're going to add a hash, okay, and then we're going to encode that URL component, the input value. We're gonna encode it, and then we're gonna pass it as the source. And then over here in the child component, if you remember, we have that interval, so we're just gonna poll, right? So we're just going to, as soon as, like every millisecond, we're gonna poll and see if that hash has changed. And if it's changed, then we're gonna change the context of that div to reflect the change that happened. So again, So this is the first attack we're going to do, and then we're going to change the attack a little bit to show you another method that we can get past this the same origin policy. So I'm going to go ahead to the browser, and I'm going to refresh this, and then let me just make sure that on the attacker server, yeah, so we've actually commented this the defense out as well. So at this point, and again, this a lot of, remember, there's a lot of forums on the web, and a lot of if you're not actually being proactive about securing your forms, and all these things can happen. And again, it could be as simple as just again a little simple message like we're seeing over here that's being passed around, and it could be just some API data that's exactly what you want, but it can also be some credentials, some user credentials that get passed around, and again, it's a huge vulnerability if it does happen to be credentials, because at that point then someone can not just take over the identity of the user like we saw in session hijacking, then essentially they can own the whole account, right? They can own the whole that whole website, and at that point they can do whatever they want. So but anyways, the way this is working, just so we can see that we're communicating across origins, it's through the hash. So if you look over here, I'm going to show you in the body itself that it's pretty hacky, okay? I'll admit it, but this is the way it was done for a long time. But so I'm going to put it over here, let's say cross cross origin policy hacked. So as you can see over here, we're seeing that after the hash, everything is being reflected on the URL, but it's not being refreshed as we would if we were to change some of the path. So since we're essentially not changing the path, all we're doing is we're using this hash as a communication mechanism. Then we can see how we can hack the origin policy. Okay, so let's go back to the child and let's change it. So eventually, the spec got around and the committee got around to changing the spec. And then what they did is, because again, as APIs became more prevalent and people wanted a way to access different resources or communicate across different origins, we needed a better way that was less vulnerable, right? And had an actual spec built out for it. So what we're gonna do is we're gonna change on the child side. Now we're gonna add an event listener, okay, and we're gonna listen to a message event. So this is when the post. What we're gonna do is we're gonna take advantage of the post message API. Okay, so that's what I'm gonna show you now. And the post message API, what it allowed us to do is it allowed us to do exactly this with sites that are cooperating. So if you are building an API and you want to cooperate with people that have access to this API and essentially, communicate across origins, then this one way that's a lot more secure, and there's actually defenses against this. Whereas this way that we were doing before, if this is the way you're doing things, or if a website is doing things this way, then it becomes very vulnerable to cross origin policy attacks. So we're gonna attach a message handler, a message listener to the window event. And then what we're going to do is, if event.origin does not equal localhost 4000, so at this point we're saying, hey, the only people that we want to have access to this is if it's coming from port 4000. And at this stage, you can pretty much set any origin you want. So you can change the host, the protocol, anything at this point. Because again, this is something that you're actually built. This is a spec that's actually built into the browsers nowadays. And then if it's not from somewhere trusted, then we're gonna do an early return. Okay, and we're gonna say, hey, you know what? We're not gonna actually share data with them. But if it is from localhost 4000, then what we're gonna do is we're gonna say div the text content, make it the event data. So we're gonna make it something very similar to what we were doing up here. But at this point, you can see that we don't have to use the hash or any of this hacky, sketchy method, and we can use the post message API, which is much nicer. So on the parent frame, all we have to change is this line of code, and then once we have again that handled to the iframe, we're going to do content window, and then the post message API. So we're going to say, hey, from that iMessage, as we've seen changes events being inputted, what we want to do is we want to get the input event. Yeah. So whenever something changes in the input, okay, what we're going to do is we're going to post it. Okay, so we're going to attach it to the iframe through the post message API. Okay, and then remember the child is using the add event listener, and they're listening to the post message. So anything that comes in through the post message, and specifically from the 4000 port, then they're gonna say, yeah, that's acceptable, and that's where this website is gonna be hosted on port 4000. So and then we're gonna include with it the input.value, right? So just send the value. Again, at this point, we don't have to encode URI component, because then the browser is gonna take care of sanitizing this for us, and we're gonna say the only website that we want this to actually go to is to port 5000, right? So if someone else maybe embeds an iframe and tries to change this, they won't be able to, right? So if they try to change a message, because the child is saying that they want to accept only messages from port 4000, and then the parent is saying that they want to send only messages to port 5000. So they're essentially saying, hey, we want to cooperate with each other, and we know this is cross cross origin domains, but in any case, because we're using the post message API, then it makes it kind of safe, a safe API to use. So this form of communication across origins. So I'm gonna go ahead and let me just restart the servers, okay? And then we're going to what we should see is essentially the same thing, but I'm gonna show you how now with this method, then the users, we can achieve the same thing. So if we wanted to implement this, for example, for an API, this would be the right way to do it. And now we're saying cross origin request. But as we can see over here, the URL, okay, is not changing. So, and everything is going through the post message API at this point, which is again a lot safer, because this has actually been implemented in the spec, and it's and safe to use. Okay, so there you go. That's one of the defense against not just a defense, but now that we have gone over the attack, and you can see how, you know, different, if someone embeds you know, a website within another frame, and then there's an input field, then someone can use this post message API or the other method we're using to essentially attack that vector. Now, if you want to completely stop this from happening, then what you need to do is not you know, if what you want to make sure is that your website does not get iframed, and because once it gets iframed, then it opens us up to a whole bunch of attacks that we can't stop. For example, someone changing the contents of the website, someone injecting JavaScript at that point, and it just becomes very, very difficult to stop. Then what we need is a new header, and the header is called xframe options. And then what you want to set it to is deny. Okay, so once we do that and we refresh this page, we can see that that page now is not being able to be iframed. And although we can type in here whatever we want, so even if someone was trying to iframe us and get the data that we were typing in whichever inputs, then at that point it won't matter anyways, because they won't be able to iframe us, and no data will be leaked into the parent or the child. So again, that's the header for that. It's xframe options, and then just set it to deny. And again, so if you're on the server, you can set this yourself, and then you're pretty much set as far as that attack is concerned. Okay, so there you go. That's so that's, you know, that's one way. Okay, if we wanted to communicate across origins, but you know, because of the way that the same origin policy is set up, we know we can't do that, right? So we need a way to get around. One way to get around is through the post message API. That's the way that you should be using. So don't use the other API, because again, that opens us up to a lot of vector attacks. So we want to use the one that's safer, and that's the post message API. Which what it does is it does a secure cross-origin communication between two cooperating origins. So as we said, it's very important to put who you want to accept messages from and who you want to send messages from. Okay, so you can't forget that part. And then what it allows us to do is it allows us to send strings and arbitrarily complicated data across origins. Okay, so because this is actually implemented in the spec itself and it's not some hack, we can actually send a lot more information through this channel, and you know, we can even send video information and a lot more complex objects. So not just simple strings. Okay. Now, another thing I want to point out here is I want us to remember that cookies do not obey the same origin policy, okay? And we saw that when we were doing the session hacking attack, okay? And the simple reason for this is that cookies were created before the same origin policy, so they have a different security model. Now, after cookies and they were implemented in '94, and I think the same origin policy was implemented in '95. What happened was that people were catching on, and they were like, "Wow, this cookies really open us up to a lot of attacks, and if we don't have a secure way that websites can request resources from each other, then that's then the web was going to be kind of screwed." So then that's why the same origin policy came into being. So cookies are, again, more specific than same origin policy, and again, at the same time, they can be less specific. So because cookies have, and again, we saw that with you can say your cookies to the same site. And then because of that, then it can be read from JavaScript, or it can be they won't be included within the request headers themselves. So that's one way to stop the passing around information across different domains. But now that we have same origin policy, and you can see how that can be bypassed, then what we essentially need to configure this and make it safer, it's is that header, which is X-frame options, and then just set that to deny, okay? And then that will allow us to abide by the same origin policies, and then we can relax it whenever we need to. So we can deny essentially any bad actors from requesting resources from our servers if we don't want to send those resources, and at the same time, we have the capability to relax those policies and send information to anyone that we want to. So again, we have, I think, the best of both worlds when we do it that way, right? So one of the caveats that I want to talk about, and one of the attacks that you should be aware of, because of these methods of the same origin policy, besides the one that we talked about, I want to at least walk you through a few other ones that you might have seen out in the wild, and again, because of the defenses that we talked about in this lesson, then you'll be able to be secure yourself from it. So can we prevent a site from embedding our site? As we saw, yes, we can, right? Now, what might be the reason for this? Like, why would you want a website to not be embedded into your site? Besides, some of the stuff that we've seen already, well, clickjacking is something that's very dangerous. And because cookies are, because let's say someone can embed your site within their website, right? So over here in this example, we have this example.com, and it's clickbait, right? So I see it on TV, and then they want the person at this point to click on this button, right? But what they're not seeing is that this eBay website, it's embedded within that frame, but it's in this example, just so that you can see, they've set the opacity to 10, but essentially you can pretty much set the opacity to 0, right? So when the person clicks that free button, they will actually not be clicking on the free button themselves. They will be clicking on the page that's on top of that frame that's on top, which will be the eBay site. And if they're logged into eBay, right? So if that session is still active and they buy that item, that's called the clickjacking attack, okay? Which is different from session hacking. But again, it's because of the same origin policy. And if someone embeds that website, then, and the way cookies are set up, right? Then at that point, 3 things have happened. They've hijacked the session. They've clickjacked they've jacked the click. So essentially, they've crossed over the origin as well. So that's a very dangerous attack. And again, this happens all the time, right? Especially with older browsers that are not aware of this stuff, or they don't have the same security policies as the same origin policy, or or against if you're a web developer and you're not kind of defending against these things can happen to your users, and they can be very dangerous. So clickjacking, again, that might be one of the reasons why you might not want someone to embed your website. So again, it's very valid. But again, if you're like setting up an API, then that might be something that you want. And again, you just have to make that decision for yourself, depending on the needs that you have and the needs that your users have and your website have. So can we prevent a site from, again, embedding our website? Yes, we can. And I show you the header for that. Another thing that I want to draw your attention to is this paper called Busting Frame Busting. It was published by Stanford professors, I think like 10 years ago, and there's the URL here for you to access it. So essentially, what they were able to do is they and in the paper it goes over a lot of examples of how someone was able to embed one website. An attacker was able to embed a victim's website within their attacker, and then they're able to perform all sorts of attack and then cross that same origin policy. So they're able to bypass the same origin policy and really create a lot of attack vectors that a victim can essentially be a victim to, that another website can essentially be a victim to. So let me just walk you through some of the options for the HTTP header for the X-frame options. So by default, this is not specified, right? So this is something that you actually have to opt into. Okay, so this is not something that's actually default in the browsers. So if you're not aware of this, then again, you're kind of at the mercy of someone being able to embed your website and then doing whatever they want at that point. Then the next option, which is the option I suggest that you set if you don't want it to be iframed, is the deny option, which is the one that we went over in this lesson. So what this pretty much does is it doesn't allow the page to be iframed. And then the other option, it's let's say you do want the page to be iframed, let's say, but that you only want it by the same origin. So only by other sites that live within the same origin, right? So that have the same protocol, host, and port. So only by those path do you want it to be able to be iframeable. Then set the same origin, set the header to same origin, and then at that point, then that will at least if you do need it to be frameable, but you don't want it to be susceptible to some of these attacks by anybody, then just set it to same origin. Okay, so now let's talk about cross-site scripting attacks. Now these are again, these are way more dangerous. So I think you guys are going to have a lot more fun, and this is something that we're going to go over a few examples on how dangerous they can be if someone's able to execute one of these attacks on a victim. And I'll show you some examples and then some ways to defend against it, as we've been doing throughout the course. So the first thing I want to do is I want to show you a very simple type of cross-site scripting attack. And I have, again, let's go over here to our bank. And what I'm going to do is I'm going to log in. Okay. And then what I'm going to do is I'm going to go to the very safe sounding URL called XSS. And then what I'm going to do is I'm going to click on this link. And then that's going to execute an attack for us. So as we can see, if we look over here on the URL changed from source. Let me close this. The URL changed from source to the fact that we're running a script tag, you can almost tell. And through that script tag, the user was able to get that person's session ID. So again, this is a different way. And then over here, it shows the script that actually ran once they clicked on that link. So, essentially, just like we were looking at for cookie hijacking, with the cross-site scripting attack, there are two types. There's the reflected type, and then there's the stored type. But all that means is the following. Let's go over this for a second. So as we were looking at for cross-site request forgery, what happens is that there's only so much that an attacker can do once they're not executing code on the user's behalf, right? So they have to get them to click a link or something. But if an attacker actually gets to run and execute code on the actual user's browser, then it really opens up the user or the victim to a lot more vulnerabilities. And so what we found out is that when we weren't running code, we couldn't do these things. For example, like we couldn't cross the iframe boundary, right? So it became there's ways to mitigate those attacks. But again, attackers have found different ways to get to run JavaScript on the page in different ways. And again, once you're running JavaScript on the page and you're not going through cross-site request forgery, then kind of everything changes hands. So let's talk about what is an XSS attack and how does it work. So essentially, is the following: an attacker sends the victim some link. Okay, now that victim clicks on the links and requests a legitimate website. The victim's browser loads the legitimate website, but also executes a malicious script. Okay, and that malicious script sends some victim data over to the attacker, right? So essentially, all it is they're getting to run some script on your browser. So it's a code injection vulnerability that's caused when an untrusted user data unexpectedly becomes code, right? And we're gonna go over again some of those examples. So any code that combines a common with use data is susceptible. So anything that's user input. Again, we talked about how dangerous it is to kind of trust user input. Well, again, in this type of attack, that's exactly what we're going to try to do. In cross-site scripting attacks, the unexpected code is JavaScript in an HTML document, or another way to for this to happen is an SQL injection attack, which a user through a user input, some type of form, right? They're able to submit a form. That form saves some code to a database, and then that database eventually gets executed and then shown to the user, and then that code that was saved gets sent to every client, right? So if the attacker gains some ability to do anything on the target, then they're essentially going to be able to get full access to the browser, and then at that point they can view, extract cookies, they can send HTTP requests, they can pretty much do anything, and it becomes really, really dangerous. So yeah, we just saw session hijacking with XSS. That's the attack that I showed you at the beginning. The attacker can insert their code into the web page. We saw through the URL, but really they can send a link. They can through a form. They can submit that form. That form gets saved, and then I'm going to show you over here on the server that I'm running right now through the request query resource. If when that form gets sent, so I'm going to go ahead and I'm going to okay, so I want to take you now behind the scenes just so you can see kind of what's going on. So I'm going to go ahead and click on this, and I'm going to go to the browser, and what you can see is that in the source, and again, this could come through a form, this can come through many ways, but essentially what's happening is that that over here, I'm just getting the source in the server, and then I'm not trying to defend against this attack at all. So the user can pretty much input anything they want, and what I'm going to do is I'm going to serve it directly into the page, right? So over here, I'm just serving that directly into the page, and then you can see it being executed. And then what I did is I showed what the execution was. So essentially, that attacker can send that information to their server and pretty much do anything else that's possible through the browser. Now, let me show you the first defense against it. So the first thing that we can do to defend against it, it's there is this great package called HTML Escape. So if we go ahead, okay, and we come over here, and I'm going to comment this out, and then so we're still gonna get the source, but now we're gonna run it through the HTML Escape function through that package, and then let's see what happens this time once we run that code. So okay, continue. Okay, let me just go ahead over here. So now we're back, and let's click on that link again. So this time you saw that the alert was not executed, so the code was not executed, and we see that the actual code that I ran actually just gets printed out as a regular string. So that's the first defense, and I would say that if you're in the server code and you have any user input, go ahead and run it through an HTML Escape function of some kind. There are many packages, but again, look for a package that does this for you. That way you don't run into any trouble. Okay, so let's see. Also, as I was making this, I was going through some of the, I kind of wanted to get a feel for how prevalent are websites to these type of attacks. And as of 2019, this is still about almost half of websites on the internet have some type of cross-site scripting vulnerability that can be attacked. So again, this is, if you're a developer, I would say this is probably your main concern. Okay, when it comes to user input, anytime you have comments, anytime you're letting the user input some data that you're later going to display back to other users, then that's a place where you should be on the lookout for this. And here are some. So if you're thinking that that a platform alone guards you from this, so we can see that infected websites by platform distribution as of 2018. Pretty much every platform is susceptible to these attacks, especially the ones that allow you to install plugins. If you don't know what that plugin is doing behind the scenes, maybe you've implemented everything correctly, but now you've installed the plugin that allows for this type of attack, and all of a sudden now you're vulnerable again. So again, I would, I would, anytime you have user input, I would try to control that yourself, and then that way you can guard against this. So again, why are these type of attacks so prevalent? Why are they the most prevalent? Essentially, is that data can be used in many different contexts. So the internet, like we've spoken about before, is this platform that at the beginning was not so not meant to be used for what it's used today. So the web has many different languages, right? So even within HTML, there are at least 5 contexts to understand, right? There's JavaScript, there's CSS, there's data, there's links, there is there's all these things that HTML has to somehow render. And when we're asking so much of the HTML parser, it essentially, and we're trying to accommodate all these languages and contexts, then it inevitably we run into this vulnerability. So if you just make, and again, remember, all you got to do is you got to make one mistake somewhere, right? So just one vulnerability, and essentially, especially in big apps, and at that point you can be completely compromised, right? So it's not like you need to it's you need to, again, all you got to do is make one mistake, right? And at that point your website becomes vulnerable. So like I was explaining to you before, also there are 2 types of cross-site scripting attacks. The first one is reflected, the other one's stored. The main difference is that reflected is essentially the attack code is placed into the HTTP request itself. So the attacker's goal is to find a URL. So either they're going to give you a link, or it's some link in some form or some place. And once you click on that link, then the attacker is going to try to perform that attack, just how we saw in the example. Now, the limitation of the attack is that the attack code must be added to the URL path or the query parameters, and also that the server has to be vulnerable to these. So they must not escape HTML. So sometimes when we're using, for example, if you're using any templating language, for example, like EJS, over here, the EJS allows you to escape HTML, and then at that point, we're not, if we use the equal sign, we're escaping it. If we use the minus sign, we're not escaping it. So another, templating languages that you're developing in probably have some this feature itself beyond HTML escaping it. So those are 2 ways that you should be on the lookout for in whatever templating language you're using. The other type of XSS attack is a stored type, right? So the attack code when it's stored, essentially what the attacker is going to try to do is it's going to try to get the code persisted into the database, right? So for example, let's say you have a comment box on some, somewhere on your site. You have maybe some comments or testimonials or whatever, and then once the user inputs their comment, whoever goes to that page after later on, then all those comments are going to load. Now, if within those comments one of them has one of these attacks, so if they were able to store some malicious code into this comment, then at that point, again, you become vulnerable, or the website becomes vulnerable to the cross-site scripting attack. So again, the attacker's goal when it's stored is use any means necessary to get the attack code into the database. Once there, the server includes it in other pages into the clients, and at that point, you're pretty much screwed. So yeah. So now let's talk about where, besides reflected and stored, let's talk about some of the places that you need to be on the lookout for that you might have not thought about before. Whenever you're allowing for a user to input some data that you're later going to serve to other users, right? So first of all, I'm going to show you in 2 ways. I'm going to show you first the HTML templates, and then I'm going to show you what are the ways to fix this. So let's say you have a website and you want a user to upload an avatar, or you're letting them upload an avatar yourself through a link, right? So again, if you have image source avatar.png, and then even in attributes, so the alt attribute, the user can input anything they want there, then that is a place where, and I'm going to show you some examples now, where a user can essentially attack, right? So this is a user data here. So whenever you see that, whenever you're going to render some user data that they input and then you later render out, that's a place where vulnerabilities can happen. Now, what are another fix for this? If you're not HTML escaping, but even if you are, instead of using single quotes, change all your single quotes to an APOS. So that changes it to, on the server side, it'll read as APOS, but once it gets rendered to the DOM, then the DOM will render it back correctly into a single quote or double quotes. Now, if you want to change your double quotes, you change it to ampersand QUOT colon. Okay, and that's a way, another way that if you have user data to defend against it. Now, what about HTML attributes without quotes, right? So again, we have the image and the URL here. Now, let's say we have, again, we're allowing a user in this example to maybe load an image themselves, right? Or maybe they have a comment box, and in that comment box, you're allowing them to include images. Now, if you allow them to include images, maybe you're saying, okay, I've escaped the single quote, right? So because we know that when they're using single quotes, they can essentially include something like JavaScript. Well, also, when the thing about HTML attributes is that HTML attributes it's not necessary for you to include single quotes in order to execute the HTML attribute. You can also include HTML attributes, and this is just, again, part of the HTML spec, as without quotes. Now, the thing is that if you do it without quotes, then you can have no spaces. So as soon as you have a space, then it gets treated as another attribute. But if a user, for example, does this, like unload equals alert, parentheses document.cookie parentheses, that's valid HTML, and then that would also get run as code. And again, there's no defense as we were like seeing over here, that you can change all single quotes or double quotes into HTML escape characters. So over here you're kind of, again, in trouble, right? So unquoted attributes can be broken out of, right? So even if you have attributes like this, then again, there are many ways that attributes can be broken out when the DOM is parsing these attributes. For example, here are just a few that can cause troubles, and HTML will still try to parse the page. But again, the best defense against this is use an HTML escape package, or a platform that does this for you, right? So again, beware of HTML attributes with special meanings. These are the most dangerous ones. For most attributes, escaping attributes is enough, like we said. If you use a package, you're usually in the clear. If you're allowing users to input something and you're escaping that input, you're usually in the clear. But again, beware of certain attributes like source attributes and href attributes, because these carry a heavier weight when it comes to the DOM, and the DOM, again, gives special meaning to these attributes. So let's say you have script source, and then you have some user data there, and right, that can never be saved even if you escape the attribute, because you're essentially allowing the user to because they're using the script tag and the source. At that point, you're letting them load in any random JavaScript, and then it'll just run in the browser. So if you're doing something like this, again, there's really no defense against this. Just be wary. When you're doing this stuff, ask yourself, is it really necessary to load in an external script? And if you do find that it is necessary, then figure out, go through that code and figure out where specifically, through some of the stuff that we've learned about in the class, where specifically you might find some vulnerabilities. All right. So also watch out for data and JavaScript URLs, and maybe for some of you that have not seen that before, let me show you what I mean by that. So there is this, and again, this is just part of the HTML spec, but most people don't even know that this exists. You can essentially write a link, that's valid HTML, and call it data text HTML, and then pass it some H1, and then that actually will get parsed and rendered as regular HTML. And then let me just show you over here. So if I'm just gonna open this in a new tab, and as you can see over here, that URL doesn't start with www, right? www. It starts with data, and then what we're doing is we're essentially treating it like an HTML document, right? So we have data text HTML, and then we're saying this is the HTML I want you to render, and again, we see that it gets rendered as regular HTML, right? So if someone gets you to, if an attacker gets one of your users or a user to, to click on a link, and the link is structured in this way, then that's a potential way to execute some HTML data that you might have not even been aware of, that was possible through the href tag, right? The other one, it's a bit more common, and most of us are aware of this, but In the href tag, you can also include JavaScript as instead of dub. So again, href is not just www. It'll HTML will recognize these and actually execute them, and then we can execute any JavaScript code, and it's, at that point, again, you're pretty much on right. So I just clicked on a link, and that link opened up a text box with the text hi. But you can essentially with what we've learned about, at this point, the user is pretty much screwed, and if there's no defense against this, then you can have a leak or anything at that point on your site. Okay, so what are the data and JavaScript links? Again, I just show you. This is how they're formed. So again, just be aware of this whenever you're allowing someone to input a link on your site that you're later going to render. And then let's go over also some other danger scenarios, right? So let a user choose a URL. So again, I'm going to go over 3 scenarios here that again, if you're taking notes, I would say these are the writer downers. Write these down because anytime I usually have a checklist when I'm writing code, and I want to check for vulnerabilities. It's kind of having like a pilot when they have a checklist or like a pre-fight checklist. So before you deploy your code, make sure you go over these things. Again, it'll serve you well. And remember, all you need is one mistake, and then you're pretty much screwed. So anytime you let a user choose a URL, get JavaScript, essentially you're allowing them to get JavaScript execution, right? So anytime, even if you're just allowing simple links, you're saying, yeah, but I'm not including, I don't let any JavaScript be included. So any script tags, essentially, is what I'm talking about. Well, anytime they have access to even a link in the URL, they can essentially, the href attribute, then that means that they have access to the JavaScript execution at that point. Anytime you let users, obviously, iframe, right? So including an iframe, at that point, of course, they have access to the JavaScript execution. And anytime you let obviously a user just load a script tag, through the source attribute, again, you've given them access to JavaScript execution, and then at that point you are pretty much you screwed. So one last thing about attributes. So now we're gonna talk about different ways that that you might have not thought of, that are not just simple use cases. And again, remember, attackers have all day to think about this. Okay, so you got to be aware that they're going to come up with interesting and creative ways to bypass even even things that the browsers and the specs try to cover. But again, the web is just too big, and these things are something that it's on every single one of us as developers to be on the lookout for. So let's say you have something that is on mouse over, and then you're executing some function, and then within the handle hover function, you're gonna have some user data there, right? So this could be whatever, right? So on mouse over, you want to show maybe an image, or you want to show whatever, a chart, anything that's gonna be essentially executed here. Well, if a user has access to the user data here, what they can essentially do is right here. So what they can do here is they can finish the function execution early with the semicolon and then close it, and then run another function with any type of JavaScript code, and then again finish the string. And at this point, I don't know if you're catching over here. So anytime you let user data, if they if they can escape, so this essentially is going to be the user data. So this is where it ends over here. This is where it starts. So imagine if what they did is that this was their input, right? So their input is going to be the following, right? It's going to start with it almost looks like a sad face, right? So close parentheses, semicolon, and then their JavaScript code. So when the DOM sees this, what the DOM is going to do, the DOM is essentially going to say, okay, so this is the end of the handle hover function. Great, perfect. Then this is another function, and the DOM's not going to know the difference, right? So the DOM is just going to then execute this as regular JavaScript as if it was intended, simply because you allowed the user to have, again, user input at this point. So again, something to be aware of, okay? So these are the little things that you need to just, catch and try to run certain scenarios before, at least on places where you're allowing this user input. So again, here's another example. let's say you have something like this, right? So let's say on your website you have let username equals user data here. So their user, right? So you're allowing their user to pick their username. Again, completely normal website behavior, right? And then what you're going to do is you're going to render it out somehow, right? So it's going to say hi there, and then you're going to render out their username. Perfect, right? Sounds good, all good, no worries there, right? So what if the user does this, right? So what if the user, when they enter the username and then they store it? So again, these, now we're talking about stored XSS. What they stored is the following. This is going to be their input. Their input is not going to be just a simple name. This is going to be their input right here. John, close the quote, then semicolon, and then they're going to execute some JavaScript code. And again, once this gets run, this part over here is going to get run like regular JavaScript, right? Because we are not escaping it, and we are going to render it out to the page. So the DOM's going to say, hey, you know what? This change, this after this closing of the quotes, and then the semicolon, that means that's a valid variable. Anything after that, now that's just, again, regular JavaScript. And since we're executing JavaScript at this point, then it's going to treat it like JavaScript, because again, we had an early execution of the JavaScript, and then because of the malicious code, then this piece again allowed it to run the JavaScript, and it became a vulnerability. So again, what are some of these fixes for this? I would say that the most obvious one is use a package that will allow you to do HTML escape. Make sure you're using a platform that allows for this. But again, change all your single quotes to you should just write a function that changes. And again, there are packages for this, but if you're not going to use a package and you want to write it yourself, at least do this, right? Change all your single quotes to ampersand APOS semicolon, and change all your double quotes to ampersand QUOT semicolon. And again, that's at least mitigates a lot of the vulnerabilities. Let's go over another example. So again, same thing on the top, right? So you're gonna allow some username. You're gonna allow the user to just pick their username essentially, right? But then again, let's yeah, this is crazy. So let's say this is what they choose as their username, right? So what they're gonna do is they're gonna escape the JavaScript execution for themselves, right? So they're gonna say, hey, you know what? This is my username. Within my username, they're gonna escape your current running JavaScript execution, and then they're gonna create their own JavaScript execution context, and then run it, and then at that point start the JavaScript execution again, so yours can start again. So again, what happens? Then what the DOM's gonna see is DOM's gonna say, okay, that this is where we're finishing one JavaScript execution. Now we're starting a new one. So again, it's like loading a new JavaScript code from externally or internally, but again, they just did it themselves. And then they're gonna go ahead and then continue your JavaScript execution to continue. So then there is no, from the DOM's perspective, there is no essentially no syntax error or anything, right? So this is gonna run completely fine. And then when you render this, hi there username, then what's actually gonna get executed is the alert document.cookie. It becomes a vulnerability, right? So what's the fix for this? So another fix to bypass this, it's again, there are libraries for this. So I suggest use a library, but I at least want you to know what the defenses are, so you can at least be aware of them, right? So you can hex encode your user data to produce a string with characters from 0 to 9 and A through F, included inside a JavaScript string. So anytime you have user input that's a JavaScript string, go ahead and hex encode it. What you will then have to do is that you would then have to decode it as well. But again, there are libraries that can do this for you, that can automate all this, and at least you don't have to worry about it, and you're at least writing safe code when it comes to XSS vulnerabilities, right? So again, inside the string, you hex encode it, and then once you are going to actually render it out, you hex decode it, and what that will do is it will turn all your strings into valid and safe HTML, right? So go ahead and that's another defense for this. And one last thing, for fix for script elements, there's this new HTML tag called template tag to store data that won't visibly render. So you can use that. And the escaping rules, again, remember this. They're simple, and the same for HTML elements, just HTML encode, and then again, look into it. Here's an example, right? So you get the template, right? username, HTML encode user data here. So essentially what this tag does for you is it does the safety check for you. And then all you got to do is, let's say you want to render out that username, you're going to go ahead and get a document like element by ID. You're going to get that element. And then all you do is you get the text content from it. And because it's inside this template, actually it's template, this template tag, then that will be saved to then do anything you need to do with that data, right? So even if you're going to store that data later on in a in your server and then render it out again, if it's coming from a template tag, which later on gets sent to your server, then at least you know the template tag can shelter you from some of these attacks. Okay, so anyways, I hope that was helpful. Those were that's what cross-site scripting is. We're gonna go a little bit more into detail here in a few more in the next presentation. But again, write these defenses down. Now you know what some of the attacks are, and yeah, see you in the next one.
All right, so now that we know a little bit about what XSS is and some of the attacks that are possible with XSS, let's talk about some of the defenses for it. So the first thing is, you know, how can this happen, right? How can XSS happen? That's kind of what we've been discussing, but let's go over it just to recap a little bit. So remember, this can happen from HTTP requests from the user, right? Query parameters, form fields, headers, cookies, file uploads, and this is mostly the reflected type. It can also come from data from database. This is the stored type of XSS. So remember those two types that we talked about. So, you know, again, if it's from a database and we're using forms to store some data that we're later going to render to a user, you know, who knows where that data, how it got into the database. And essentially it's, you know, if you're worried about security, which it should be, of course, then it's not okay to just trust that, you know, just trust that nothing can go wrong, right? Or to leave that responsibility completely 100% to the browser, right? So we actually want to take some steps ourselves to mitigate some of that. And also it can come from third-party services, which I think it's the most prevalent. So like, let's say you install some extension or using some library, you know, anything like that, especially as a developer where we're constantly using a lot of libraries just to build our applications. One of those libraries can have a vulnerability, and it might not be in a malicious way. Like it could just have been there. And again, like it's just maybe not fixed. And, you know, this happens, I don't want to say all the time, but it's happened before. So again, it can come from third-party services, and you know, so even if the server gets hacked and you've done everything on your end, but then you're loading some library in, you know, at that point, you know, your users and your website can become vulnerable to XSS attacks. So the first defense that we talked about is escaping, right? So most of the you know, and like let's talk about this and when should we escape the code base, right? So if let's say we want to sanitize some of this code base, whether it's reflected or stored, when should we do it? Okay, when should you be escaping these things? So the best way to think about this, and again, like this is more like a philosophy more than anything, it's always on the way out, right? At render time. And why? So like, let's say if your application is small and you're the only one working on it, that's perfect, right? But again, even then, you could be loading third party libraries. So at that point, even if you don't know that you're working within a team, essentially you are, right? Because you're trusting all these other developers that you're loading their scripts in, that their code is also safe. So one way just to mitigate this, and then just think about it from here on out the same way, is just always sanitize it on the way out, right? As before you're about to render, just assume anything could be compromised, and then just do it before you're about to render. That way you can just, you know, it's a good philosophy to adopt. And then I would say just get used to thinking in that way, and it'll, you know, it will at least get you in the habit of a good security model for you to think of. So the other thing is use the default that comes with whatever templating language you're using. Earlier we showed how you can do this in EJS, but even in React, pretty much every language or every platform or every templating platform, it's gonna have a way to escape it, right? So in EJS template here with the equal sign, we showed how you can escape it. Remember, if you put the minus sign, then at that point it'll run the code. But again, all the major libraries bring this, and again, just use that as well, right? Instead of actually, you know, maybe like creating your own way or just hacking it, just if you're using a templating language, know that some of this is already built in, and then that should give you some peace of mind. Let's continue on here. So another philosophy that I want to impress upon you is that remember that the chart I showed you, where as far as attacks are concerned, XSS is one that's pretty prevalent, right? So one of the things, it's just one of the most common vulnerabilities, and one of the things that we could do, it's like how can we defend our sites, in the presence that XSS is as big a vulnerability now as it's ever been, right? So remember, with XSS, the attacker code is running on the same page as the user data, right? So at that point, it's kind of like anything goes, right? So they have access to the cookies, other private data, whatever. As long as an attacker is running code on the user's browser, at that point, it's kind of game over. So how can we prevent this? Knowing that, let's just go into it thinking like, you know what, this is probably going to happen. But even if it happens, what can we do to prevent it? So the key idea here is a concept that's known in security as defense in depth. Okay, so instead of us focusing just on like one defense, what we're going to try to do is we're going to try to apply multiple defenses. So that way, if the attacker gets access to something, then they still have to get past other defenses in order to to execute the full attack, right? So now the attacker again has to find multiple exploitable vulnerabilities, and then this makes it harder. At least you mitigate the damage. One example where you see this all the time, and it's becoming more and more popular, is two-factor authentication. Right, so let's say you forget your code or your password or something, and you're trying to log in. You can reset the password, and let's say someone has access to your email, so they'll be able to authenticate it and all that stuff, right? But then maybe they also need to have access to your phone, and then they're gonna send you a verification code that goes only to your mobile number, right? At that point, the attacker actually needs to have both of those things in order to take over the identity and in order to execute the attack correctly. So again, that's so that's the key idea right there with defense in depth. Also, let's talk about defending the user's cookie, right? So one way we talked about it's so now that we have this concept, let's see how we can apply it and layer these defenses on. So the first one is, remember we talked about cookies. So one way to just defend against this is make it just HTTP only. So if you remember back from earlier sessions, that stops the attack that we're seeing right over here. So the one I'm showing right here, so new image source, and then where the attacker is kind of sending the cookies out, through the image, and essentially exploiting that vulnerability. Then once you make it HTTP only, remember it won't be able to get read as JavaScript, right? So that's the first defense that everybody should be using now that we know about this, right? And then that mitigates a lot of session hijacking and things like that when it comes to identity on the web. The next one is content security policy, right? CSP. So CSP, this is a new header. So previously we talked about ways to tie up same origin policy. Now what we want to talk about is in terms in which sites could post forms to our site or load images, scripts, or styles from our site, okay? All right, so let's talk about content security policy, or CSP. This is a new header that I want to introduce you to. Whereas before, remember when we were doing cross-site scripting, we talked about the same origin policy in terms of which sites could post forms to our site or load images, scripts, or styles from our site. So, anytime anything was coming from another site, we would prevent it with the same site header, if you remember that. That's preventing other sites, right, from making requests to our site. And that seems logical because if you remember, when someone can kind of load a script into our website, then that becomes vulnerable. But CSP is actually the inverse, right? So what we're trying to do with CSP is prevent our site from making requests to other sites. Okay, so now this is from our site making requests to the outside. And you might ask yourself, why would we want to do this, right? It kind of seems like a good idea that, let our site make any type of request. But remember, what we're trying to prevent here is with XSS attacks, what's happening is that someone has code running on a website already, right? So the attacker has gotten their code to run on a victim's website. And then at that point, they can make external requests for example, and then leak some data, right? So that's kind of where you want to prevent that, right? So when you're dealing with an XSS attack, that's why CSP comes into the picture, which is you want to prevent your own website into making requests to the outside to other websites, right? So that's kind of the inverse of what we talked about with the same origin policy, right? So this is a new header, like I said, and it's called content security policy. You set it in the response, okay, and it allows you to do is it allows you to control the resources the page is allowed to load, right? So CSP blocks HTTP requests, which should violate the policy. So in this case, you're the one setting the same origin policy, right? So since by default, your website can make requests out to kind of anything and load whatever you want it to load, right? So through script tags, style tags, whatever. At this point with CSP, it gives you some control over what resources do you want to, like if someone's trying to make a request, right? So if you're trying to load something from an external request, then you get to control that. So let's see how we can do that. So the goal here is let's say we say, hey, you know what? Only allow requests to happen if they're to our own origin, right? So like let's say they're trying to leak some data out through this attack here, right? So they're gonna use they're gonna load an image, and then through that image, then they're going to leak out the document.cookies. Okay, perfect. So what we can do here is we can set the content security policy and the default SRC to self. So now even if they're trying to make an external request and leak out something, then that won't be allowed because that's to a different origin, right? So instead of, again, working in reverse where someone's making an external request and trying to make the server serve something, this is coming from the inside, and then you're setting the policy and you're saying, hey, you know what? We don't want anyone to make external requests if it's not to our own domain. Another goal is content that comes from our site plus the trusted subdomains, right? So like, let's say, for example, that you want to load, I don't know, Google Analytics, right? So at that point, you might want to say, okay, I have a lot of content that most of the resources come from me. But let's say you're using a CDN and you want to load stuff from externally from the CDN because you're caching, or you want to load it in Google Analytics. Well, at that point, that's not the same origin. So how do we fix that with CSP? Well, the way to fix that is you add a star, and then you get to add any trusted subdomains, right? So you get to have like a whitelist essentially of domains that you want to trust, right? Now, one thing I want to caution you before deploying CSP, it sounds great, right? And like now we have this way to mitigate XSS attacks, but now again we have a problem. So how do we figure out what the policy should be, right? Because like at any point, it's very fragile, right? Like what if we're missing something, right? Then at that point we can, like if you just apply the policy right now, and like let's say you had Google Analytics running, then that will break your Google Analytics, right? That will break your CDN. So there are many things that you have to consider when applying CSP that might make it fragile and might make it not worth the time, although it does stop XSS attacks, and it is a great policy. So what's the solution? So the solution is, there's a few solutions. So the first one is we can deploy it in report only mode, right? So that's, again, another header called content security policy, and then add report only and then the policy. So what this would do is, it won't necessarily stop it, but what it will allow you to do is it will allow you to get a report every time an external request is being made, and then at that point you can decide what to do. So over time, what you will see is, instead of like making guesses in a vacuum, this way, as you build up your report will tell you all the external requests that are going out, and then this way you get to see what's happening, and then that way you can make a pretty robust CSP policy that actually covers your use case. So again, now that's one way to detect XSS attacks. So how do we catch XSS attacks that are CSP blocks so we can fix the root issue, right? The solution is enable policy violation reports. So not just can you enable it in report only mode, right? So, and this is the way to do it. You can put the default source to self, okay? And then pass it in a URL or a URI that that the report can post to. Okay, and then this could be in your own server, and then you can save it to your database. Like this is what I would suggest you do at the beginning, and this is the way to set that the report only on your content security policy. You set the default to self, and then you give it a report URI, and that's what you include in your response header. And then this way, you will get a report every time, and then you can decide what to do with that report at that time. So if it's like Google Analytics, then you can add that to your whitelist, and then there's no issues, right? Now, here again, so CSP is it's actually pretty in depth, and it's pretty like involved. But I just want to go over some of like we don't have time to go over every single one, but I just want to make you aware that like this is how complex complex the policy you can make it, right? So you can make it as unique as your use case is. Okay, so the default source, this is the kind of the default thing that serves as a fallback for the other directives. So if you include none of the other directives and you just include default source, it'll kind of stop like, everything, you know. But there is also a connect source. This restricts sources from script interfaces. Font source. So if you're if you're making a request to load in fonts, you can create a whitelist of fonts. The frame source. This restricts sources for nested browsing context. So iframes and things like that. The image source. If you're making an image request to an external site, then that's you can set the policy to not allow that or allow that, and provide it a whitelist. Media source. So again, this is for audio and video. So again, it's like I said, it is pretty involved, but probably the most important one, it's this one, which is script source, and this restricts sources for script elements. Okay, so that's again, read into CSP. It's a great policy. It is a way to stop XSS attacks, but it is kind of it is kind of fragile in the sense that if you miss something, right, you can be breaking something in a site that you didn't intend to, and has nothing to do with XSS, right? Because it is so restrictive. Okay. Now the other thing that it does is that script SRC blocks inline scripts, so it doesn't just block someone from loading in a script tag from the outside, right? And that's kind of what we were expecting, but because when this header was created, the purpose was to stop XSS attacks. Then if there's an inline JavaScript, okay, injected into the website, by the mere fact that it's inline, then script SRC, this CSP policy, would actually also block all inline scripts. Okay, so the better solution for this would be to move the code, instead of writing it inline, move it to a file that's hosted on your site, and then load it in that way. That way it doesn't get blocked just because it's inline. But again, this is something you have to know. Be aware of it. There's a lot of like gotchas and caveats when it comes to CSP. So there you go. Now, because of all these caveats, there are and like since this has been implemented, there's a lot of breaking changes. So a lot of people are shying away essentially from using CSP as a way to do it. But there's a better way that we can accomplish kind of to stop XSS attacks, but at the same time make it dynamic enough so that let's say we're trying to load Google Analytics, right? But then Google Analytics has other scripts that is loading from let's say other servers that they have, but you didn't include that in your whitelist, right? So now again, you go back to the point that it's great when it works, but it's very fragile because you have to take into account all these edge cases, right? So the question is then, is there a way that we can mitigate, okay, so that we can propagate? Once we say we trust the domain, like anything that domain loads, then we're going to trust it as well, right? So it's kind of like a blanket statement. Once we say we're going to trust one origin, then anything coming from that origin, images, scripts, whatever, we're going to trust it as well, right? So this allows us not to have to specify all these whitelists and to not have all these edge cases. And the way to do this is after you script SRC, you pass in strict dynamic, and then you set a nonce, okay? And the nonce, essentially what it is it's a dynamic value that you can set, and any script tag, okay, that you include on your site later on that you're loading, as long as it has that nonce value, then it'll be allowed, okay? And then that way that's kind of that kind of sets it so that you don't have to set the whitelist anymore, right? So no need to specify that. The nonce, like I said, it's a dynamic value. So although right here in the example I'm showing nonce ABC123, again, like this could be randomly generated, and we've talked about how to like do secure random generation in previous lessons. So if you forgot how to do that, then go back. But you can essentially generate a random nonce, and then on the client side, any script that has that nonce would get whitelisted implicitly, right? Like you do not have to do it on the server side. All you have to do is pass in struct dynamic, pass the nonce and the value of the nonce, and then on the client side include that nonce with every script that you yourself want to allow. So if an attacker actually does get some code into the into a user website or into a user context, because the attacker won't know what that nonce is because it's been randomly generated, and it's, you know, if you do that correctly, it'll be very hard to brute force that and like guess that. Then that way we kind of get you know, we kind of get the best of both worlds. We can stop the XSS attacks while at the same time not have to deal with all the edge cases that come with CSP. Okay, so here I went ahead and look at and got for you kind of a starting boilerplate. So if you don't know where to start with a CSP, here's a good policy to start. But again, remember, every use case is different. So and yeah, of course, with this course, all the slides are included, but you know, so you don't need to just copy it, just get it from the slides. But this is a good starter. You know, this is a good starter CSP header, and I say reasonable because I mean this is crazy, and it just kind of gives you an idea how like complex CSP is. But this is a good one though. Like, you know, this is one you can if you don't know where to start, use this one, and then as other edge cases arise, then deal with them then. Okay, but this is a great one to use for yourself. So feature policy HTTP header. So there are other policy that which is there's another header that you can set, which is called feature policy as a response. So again, this one's like not as this one also stops XSS attacks, but it stops other type of attacks that I think are going to become more prevalent. Again, this one's pretty new, so I just want to make you aware of it. It's called feature policy. Look into it. But what it does is it selectively disables browser features. Okay, so things like autoplay, geolocation, picture-in-picture, vertical scroll. So these are things that, again, these are more in-depth attacks that can happen not be like with XSS. But again, this is like pretty nuanced. And again, if someone is doing this to your website, it's at that point, you know, maybe you should look into you know, just look into the feature policy header, okay, because it's also pretty in depth. But as new devices, more and more devices, right, IoT and things like that, you can imagine that. And as these devices are connected to the internet, and as we want to provide APIs, yeah, security is going to become kind of an issue. So we're kind of in this like middle point now, okay? But at least I want to make you aware that these things do exist. So again, what I suggest is follow the links. I'm going to provide links here under the video. So click on those links. It'll give you kind of you know, a better understanding of like these more in-depth subjects. I suggest, again, if you're getting into security, that you know, you become acquainted with this because it's going to become more and more useful. Again, if your company deals with security, or if you want to start a company that deals with security, like these are things you should know anyways, and it allows you to create value for your users. And you know, beyond being just a developer, I think if you're going into like pen testing, yeah, these are things that are going to become way more useful and way more important in the future. So final thoughts on XSS, just to wrap up here. So XSS vulnerabilities are pervasive in the real world. Okay, they're, you know, pretty much even with all these policies that we have, XSS is still a problem. There's still, you know, probably over 50% of websites on the internet have some type of XSS vulnerability. So again, it's still an issue. But you know, these are like some ways that you can mitigate this. And remember, as you layer these things on, you increase your chances that you won't become vulnerable to one of these attacks, right? So remember the philosophies that we talked about in depth, okay? Like layer your security, use more than one technique. That way the attacker can't just like, you know, attack one vector. They have to go through many things in order to gain access to, you know, and like make a system vulnerable. Okay, be aware of the context you're including your user data in. So if you do want to include, so for example, like let's say using React or Angular or something, like be aware, okay, that someone can actually run JavaScript within those languages and it'll get rendered as JavaScript simply because of the way that templating language is set up. And that's, again, that's the expected behavior that you do expect. But when we're thinking from a security standpoint, just be aware, okay, that someone can run JavaScript because it's already running JavaScript, right? So the templating language itself, although it looks like HTML, it's actually like, for example, like if we're talking about JSX or something, which is the React templating language, right? That's JavaScript. Okay, it looks like HTML, but it's not. It's JavaScript. So again, just be aware of the context you're using, and you're including your user data in, right? And then one last thing, UCSP. That I think will cover most of the use cases. It will if an attacker is just phishing and just trying to attack a wide range of for like websites that are vulnerable, at least yours, will become harder, and maybe they, will just move away and not deal with it because you have all these things in place. Okay. So, anyways, hope you like this part of the course on XSS. I think it's super important again because so many websites are vulnerable to this, and it is hard to stop unless you know the defenses. Now that you do use them, and I think it'll put your site and your users in a place that makes them a lot more safe. Okay, so anyways, hope you enjoy. See you in the next video.
All right, so now we're at the end of the first part of the course, and we're going to cover denial of service attacks, phishing attacks, and some final thoughts I want to leave you before we finish the client side part of web security. In the second part of the course, what we're going to cover is the server side. But for now, we've seen most of the attacks and most of the things that we need to be aware of when it comes to client side web security. And then in the second part, we'll cover everything that we need to be aware of on the server side. So let's get into denial of service and phishing. I'm going to show you some examples. I think this will be a fun class. It'll be, I'll try to keep it short because I think we've already covered some of the most important things. So let's get into it. The first thing I want to bring your attention to is tab nabbing. So I don't know if you ever heard of tab nabbing, but tab nabbing pretty much is, let's say you're on a forum or a message board or whatever, and an attacker posts a link. Now the link has this this property that says target blank, and I think we saw this before, but if you don't remember, target blank is what allows you to open up a new tab, right? So an attacker post this link, the link looks completely normal. That's not actually where the attack takes place, but it has this property that says target blank, and then the user, once they open it, they kind of go to this other page. So let me just show you what the example is first, and then I'm going to explain to you how it is that it happens. So let's open up that link. Okay, and let me close this. All right, so let's open up that link. And let me put this full screen. And then I just want you to watch what's happening on the screen over here. All right, so they're going to make a link. And then they're just going to post. So the link looks completely normal. Now, here's the thing. So as you can see, they're on Reddit right now. Okay. So now someone else is going to come and click that link completely normal. Now, the thing is that Reddit doesn't want people to leave their site. So what Reddit will do for them is Reddit would actually open up a new tab for them, right? But now behind the scenes, okay, I don't know, let me just rewind this so like you're aware of what's going on. So behind the scenes, if you look over here, this site is changing, okay? And now let's pause it for a second. You see that instead of saying Reddit, there's like an added D to it. So they've actually, what they've done is, while the users on the other tab, they had a reference to that other window, right? The Reddit window, right? So if you remember what we talked about, once we open up a new link to a new tab, now we have a reference. This is like an iframe, okay? So anytime we have a reference to another window, we can control that window. And what they've done is they changed the URL in that window to somewhere else. And now what they're doing is the user is trying to sign into Reddit, but of course this is not Reddit, right? So it says incorrect password. Now over here we see that what's been going on is when they enter that information went to the attacker server, right? And now the attacker has that user's username and password. And again, this is very tricky, right? This is actually very hard. I would say if, like this is an attack that, and I'm aware of these type of attacks, and this is something that would be very hard to catch even for someone like me, right? So this is what tab nabbing is. I just want to make you aware of it. It's a very difficult attack to catch, but again, it's out there, and I just wanted to show it to you so that you're aware and that we cover all our bases. Okay, so let me move up here. All right, so again, this is kind of how the attack would take place. So if you just want to have the code as reference, we're pretty much opening up a new window, and then we're checking if the parent location, if we're still on the same, if we're not on the parent tab, then what we're gonna do is we're gonna change it, and if we are on it, then we're not gonna change it because we know that the victim now has been on our that the victim now is on our own URL that we wanted them to be on anyways. So that's tab nabbing. Okay, so that's a pretty crazy one, and it's pretty hard. So there you go. So what's the defense for this? So whenever especially as we're developing, one of the things that you can do is you can add a new property to your link tags and called rel. So the rel, just set the rel to no opener. And what this will do is this will allow all the links with the target blank to prevent to have that attack. Okay, so it won't allow anything. So it won't allow it essentially for that user to get a reference to that window. Okay, so it won't be binded to the window, right? So the open window sites will be null. So there won't be any anything that the attacker can use in order to get access to that other tab. Okay, and there's also kind of rumors of a new HTTP header that browsers want to include or introduce, and it's called cross-origin opener policy. So again, I think we don't know when this is going to come online or if it is at all, but anyways, it's something that browsers have been talking about, including in the spec. If it comes, great. If not, it's a hard attack, and yeah, I just want to make you aware of it. Another thing I wanted to make you aware of it. Oh, actually, I think I skipped over this. So one of the things that I also want to talk about, which is where we left off in the last lecture, is as we've seen throughout this course, as we want more and more powerful browsers, okay, then what happens is that inevitably we have to allow the browser to have different levels to the API, right? So the browser is going to have access to a camera, for example, which at the beginning it wasn't that way, right? The browser can have access to your file system. The browser can have access to all these things in the API. And I wanted to show you kind of the levels of API, and the levels, the way they're divided up here is kind of dependent on whether like an attacker can just actually execute the attack without any intervention, to all the way to level 3 where a prompt comes up on the browser. So for example, if you're trying to use a user's camera, a prompt will show up and say, hey, do you want to let the site have access to your camera, right? So that's level 3. Level 0 are all the attacks that can be implemented, or all the APIs that, okay, so let's not call them attacks, because these APIs, although they can be abused, that's not what they're meant for. So, but browsers have come to the realization that they do get abused. So depending on that, they'll execute some type of prompt, or it'll take some type of user behavior in order for that part of the API to be to become active, right? So all level 0 APIs are APIs that kind of have no restrictions, right? The API can be used immediately without any behavior kind of on the user side, right? So these are DOM, CSS, window.move, file download. So yeah, I mean, that's a pretty crazy one, but pretty much anyone can download a file without you actually clicking on the download link. And there are good use cases for this, but anyways, that it's part of a level 0 API access. And the move mouse cursor, this is also level 0, and it makes sense because this could be implemented just simply on CSS with the CSS property. But in any case, if someone hides like the cursor mouse, and then other attacks can be implemented because through JavaScript they can make a new cursor that looks like the old cursor, but it's not. It's being actually controlled by JavaScript, right? And then that's a way that an attack can be implemented. The level 1 APIs, the user interaction is required, so the API cannot be used except in response to a user's activation. So example, like a click or a key press. So when you click on something, someone can allow for a prompt to happen, or something, once a user clicks on a link or on a button or something on a page, for example, then maybe we can load a video, or maybe, for example, we can give them access to the camera or anything like that, right? And some examples of these are request full screen, navigator.vibrate, copy text to clipboard, speech synthesizer, window.open. So all these kind of, again, it's still pretty low level, so it's not like it takes an incredible amount of user interaction, right? It's not like a prompt is going to show up in order for these APIs to become active, but it still like at least requires that the user moves a mouse or does something, right? Like they need to actually interact with the page themselves before the attack can even happen, or before this API can be engaged. Level 2 API levels, level 2 access, it's required that the user does engage in a more meaningful way. So the API cannot be used until the user demonstrates high engagement. Okay, and again, yeah, this is a moving target, but yeah, they need to demonstrate some type of engagement with the website. So, for example, autoplay sound, right? So now by default, websites won't autoplay sound. So the user actually has to click on, that they want the sound to be active, right? So that's a, although it's not a prompt, it's definitely a the user is explicitly saying, hey, I want this to happen, right? And at that point, then the API becomes available. Prompt to install a website to the home screen. Again, this is something that the user actually has to go out of their way, right, and say, yeah, I want this to happen, right? And these are level 2 API access. And then level 3, which the user permission is definitely required. This is not just engagement, but the user has to, for example, click on a button and then a prompt to show up, and then they still have to say, yes, I want this to happen, right? So it's that kind of level of interaction. And the APIs that fall under this category are camera, microphone, geolocation, USB, MIDI device access. So, pretty much anything that has like pretty low level access to computer resources or things like that. That's kind of the level 3 API access. So again, as we've been talking through some of the attacks, I also wanted to, because I know we left off in the last course talking about APIs and all the API that are available through the browser, and we've been talking about that since the beginning of the class. So I kind of wanted to categorize them for you and show you kind of where they fall within this level of categorization. Okay, so now you have an idea, and again, I suggest go ahead and read up on some of these documentation. I'm going to put some links up as well, so you can actually get a more in-depth, some more information on all this. The next thing I want to show you, it's this great paper. It's called "Most Websites Don't Need to Vibrate," and again, I thought it was a pretty interesting paper. It was brought to my attention by a good friend of mine, but it's a cost-benefit approach to improving browser security. So again, it's a paper that was brought in, and they're kind of analyzing whether, are all these things pretty necessary, right? Like, do we need to have all these? Do we need to allow the browser to have all these API level access in order to deliver a good experience on the web? And if the answer is yes, then how should we move forward with this, right? And I think this is an ongoing conversation. But it's something, especially if you're getting into security, I put a link up here for you to check out this paper. But if you're getting into security, and especially web security, read this paper. It's a pretty interesting read. It's a good read, and I think you get a lot out of it. And then one last thing I wanted to show you, which is a phishing example. So let's see here. So and again, I after this, I want to show you. I want to leave you with some final thoughts before we part. So this phishing example, again, this is like one of those things that's pretty hard to catch. So let me just play this video and see if you guys can figure out what's going on here. All right. So a person comes to a page, okay, and now they're scrolling up and down. But you see, as soon as they scroll down, this URL, I don't know if you caught that, right? So they're first on this regular URL, and then it changes to a bank URL because they scroll down. So what the attacker's doing is they've kind of iframed their website within the user's profile, and as they start scrolling, what then the attacker is going to do behind the scenes is going to change the frame URL, but at the same time is going to keep on top of that frame the same website that was there before. So from the user's perspective, visually, right, it looks like nothing's happened, right? But if we look at the URL up here, then we can certainly see that now the user has been navigated to their banking URL. And of course, at this point, anything is fair game, and we've already looked into some of the attacks that can happen over here. But again, cookie hijacking, session hijacking, cross-site scripting, like, can become a vulnerability at this point. And the attacker pretty much has full control, and at this point they can do almost anything. Okay, so again, I'm gonna leave a link up for this. This is a great article. I think you should check it out. But yeah, that's a phishing example, and it leads us to one last quote I want to leave you with for this part of the course, and it goes like this: like, as we've been talking about, right? Security solutions, and this is a quote by Bruce Shiner. Security solutions have a technological component. They do, and as we've seen, that's kind of what we've been covering throughout all this. What the attacks look like, how they're implemented, what are the defenses we can execute against them to cover ourselves and our users. But essentially, security is fundamentally a people problem, right? And that's, specifically, especially phishing really showcases this. That at the end of the day, like, anything can happen if an attacker can get access to not just a computer, right, but a user themselves, right? So it's people error that can sometimes cause the biggest vulnerabilities, and not so much the securities or the APIs that the browser might have or anything like that, right? So if a person makes a mistake, which usually it's what happens, that's where a lot of vulnerabilities are going to come in. And as you go further in your career as a pen tester and or as a developer, it's important to keep that in mind, right? Users are users are not predictable, okay? And no matter how much we want to make the web a safe place, the mere fact that at the end of the day, it's going to be users using the web and people using the web, then vulnerabilities are always going to be a presence, okay? And it's my it's my belief that we shouldn't, it's not that we shouldn't work towards making a safer web. We should, but we should be very careful about how we think about this, right? Because at the end of the day, if we put ourselves in a position where the web becomes this place where nothing can be trusted, and we lose this ability to communicate freely and to share resources. And I think the web is only getting better as time goes on. Although you can see that it does bring with it its own caveats. I think the benefits far outweigh any repercussions or any of the problems that we're seeing on the web. And again, that's just my belief. Anybody can have their own opinion. I just want to show you, and I just want to show you from my perspective what I think. And one more thing, thank you so much for watching the course up to this point. I hope you've gotten a good education. I hope you're I don't know where you were at the beginning, but I hope by now you at least have a good grasp of some of the attacks that are the most prevalent that you should defend against. And now that you have some of those skills, I think the second part of the course, you're also going to love it, which we're going to cover now all the server-side part of web security. Okay, so thank you so much for watching up to this point. Please, leave me some feedback. If you have any, I'll try to come back, update the course as I get some feedback. But in any case, I hope you enjoyed it, and I'll see you on the next course. Take care.
All right, in this lecture, let's start going over server-side attacks. Now, the first thing we want to go over is code injections, specifically SQL injections. Now, SQL injections are very still, just like XSS attacks. There's a lot of servers that are vulnerable to these type of attacks. And again, there's a lot of books and resources when it comes to SQL injections. SQL injections have been around since pretty much forever. And pretty much what people have found out is that because of the way forms are, we're not even talking about the web at this point. All we're talking about is clients and servers, okay? Now, on the server side, because usually the way code is written, and sometimes since it's not sanitized, remember we talked about this in previous videos, the server is kind of vulnerable to the same attacks that we were discussing previously on the web client, okay? Now, the difference is that if you can execute, or if an attacker can execute some type of code on the server side, it's a lot more dangerous because you actually do have access to the shell and to the terminal, right? Because you're just already on the server. So there's not going to be if an attacker is able to execute code on the server, then at that point there's not all the security features that the web has, right? Because it's kind of implied that if you're writing code on the terminal or on the shell, then at that point that you have access to that server. Okay, so again, that's kind of why XSS attacks versus code injection on the server side, which is like SQL queries. And again, remember, this is stored. This is the difference also between stored XSS and reflected XSS. But in this lecture, where we're going to be going over the attacks are more when something gets executed right on the server. Okay, so let me just show you something really quick. I'm gonna come over here, and we're still working with the same server. Okay, I added kind of a new script down here, and all this is gonna do is it's gonna concatenate a file. So I've created a file over here that's just some lorem ipsum, nothing really special. So let's go ahead and see what happens when we output that file. So again, what we get it's the echo back on the server. Okay, and that's what we get on the terminal here. Now, as we can see here, we're just doing this pretty naively, and what we are doing is we're saying, hey, whatever that as the second input, whatever we're getting as a second input, then serve it. But let's go ahead and see. Let's say that the user input. Remember, we've been talking about user input, and the way we should think about it is that pretty much the user can input anything into any form. Okay, and especially if there's a form or if there's something that's going to get sent to an endpoint on a server, then we can expect that the user is always going to behave as expected, okay? So we kind of have to defend against all these things. So what I'm going to do is imagine if a user put in not just file.txt, but then they also typed in ls, okay? And then what we're going to get now is actually outputted the whole folder structure of the server. And that's, that could be pretty detrimental, because it's not just that they can do that, but they can do things like RMRF, and then delete the whole website, the whole database. Let's just do something fun here. So if you really want to freak people out, here's a good one. Say hello world.
Hello world.
So there you go. And again, it spits out it spits out the regular file.txt, but then the attacker executed another command. Okay, so this is kind of what we want to go over in this lecture. These type of attacks that are executed on the server side. Okay, now I'm gonna go ahead and close this, and then I'm gonna start up a server. So we're gonna go back to the client now, and let's begin over here with this same type of attack, and let's see how it can affect us on the browser side. Okay, so if like I said, what we're gonna do is the same thing here, and actually I'm gonna go ahead and for now, let's go ahead and do the same thing, but we're going to send back to the user the output. Okay. All right. Let me see. Do I need to actually? Yes, I'm gonna comment this out, because then I'm gonna show you the defense against this. But first, we're just gonna execute the attack now on the server side. I mean, on the client side. Okay. So let's go ahead and let's just start the node server. Perfect. And then let's go to this endpoint over here that I made. All right, so now we have a file viewer. Okay, so let's say that we kind of have the same thing that we were doing before. Now the only difference is, so we're gonna get a query coming in on the file name, and then the standard out that we're gonna get is we're gonna get a child process, and we're gonna execute that same command. So essentially, imagine that the user is having this. Imagine we have something like Dropbox or something, right? But we're doing this pretty naively, and then the way that we wrote that code on the server side was just to output whatever the file that the user looks for. Then we just want to give that file back to them, right? So we just want to show them that file. So let's go ahead and do that, and let's see what we get back. So I'm gonna put here file.txt, and what we should get is the same thing, right? So now again, it's just the same thing we're running on the server, but again, now on the client side. I'm gonna refresh this, and then let's see if we can actually access from the client all the server files, and then see if that server actually outputs the whole file structure. Instead of just doing ls, let's go ahead and write on the file viewer with the flag r, so that way it's recursive, and let's see if we can actually get a whole file structure. So like pretty much the whole buffer should get filled out here. And there you go. That's kind of our whole application, right? So if someone can get access to this, and again, as far as we know, there's still a lot of sites that are vulnerable to this type of attacks. And this is, one of the best ways to check against this stuff is just knowing what the SQL commands that can be executed on that server are. And if you're a developer or if you're a penetration tester, then these are the type of stuff that you need to be guarding against. Okay, so as you can tell, an attacker was able to execute a command on the client side, and the server kind of gave them. So what we expected was a user just to put in a file that they wanted back, right? But again, since we allowed that user to just type in anything in the input, at that point we're kind of opening up ourselves to all these type of attacks, and an attacker now can see kind of our whole directory structure. And again, if you have any files here like a database or something, then the attacker can at that point know where your database is located. Knowing where your database is located can also give the attacker then access to doing different types of attacks. So now they can target your database, they can target some information, and again, it's an entry point, but it's an entry point that exposes the server to pretty much any other attack that the attacker can execute at that point. Okay, so all right, so now we have that. Now let's go to the bank application. Okay, and I'm going to now before we move on to the next exercise, I want to show you one last thing, which is the defense for this. So what you want to do is one of the ways to defend against this, especially on the server side, it's so let's see here. So we're going to do the same thing, right? So instead of child process and executing it synchronously, what we're going to do is we're going to spawn sync, okay, which is again in every in every language, this will be a different command. So just figure out which one it is we're writing in JavaScript. So we're going to spin up a new we're going to spawn up a new process, and we're going to say, hey, we want to run these two things separately. Okay, on one end we're going to specify what it is that we want to run, so the command, and then on the other end we want to say this is what you should run through that. Okay, so again, now what we want to see is how does this defense guard us against the attack. Okay, so let's try that same attack again. And I'm going to refresh it just to make sure, and then I'm going to try the same attack. Okay, and now what we get back is cat file text lsr no such file or directory, right? So what are we doing? So we're saying, hey, this cat command is going to get run, but then it's going to concatenate kind of the whole thing. So you see what we're saying, we're getting a no directory error because this whole thing gets sanitized together. Okay, so it's kind of saying this thing called cat file.text lsr that doesn't exist. Okay, because again, it really doesn't, because it's running the two commands separately. So at this point, then we get the expected behavior. Okay, and someone couldn't just string along many commands and then execute arbitrary code on our server. But still, if we just type in the expected file.text, then it'll spit out the correct output. And that's exactly what we expect. Okay, so again, this is just a way that someone couldn't just string along, right? So they couldn't terminate our process, and then after terminate the process, then run another command, right? That's kind of what we want to guard against. And then that's kind of defense. So what we want to do is, again, on JavaScript is we're gonna spin up a new process, and then what we're gonna do is, since we have two processes kind of running, we're gonna say on one end what the command is that we want to run, and then on the other end kind of the files what the input is. Okay, and now in this case we're getting the input, yes, from a form, but you can imagine this can come from anywhere. Okay, but at least it guards against like I said, being able to string along many commands and then having the server naively just executing these commands. And again, it just exposes us to a lot of vulnerabilities when someone can just execute arbitrary commands on the shell or the terminal. Okay, all right. So let's move on. I'm gonna start the server on port 4000. Okay, let's leave it there. And now what we want to do is we're gonna start up a SQLite database. Okay, and now we are going to go over SQL attacks. Now, SQL attacks are very similar to what we just reviewed. Okay, so we've already seen, again, on the client side, we've already seen cross-site scripting attacks, and this is again very similar simply because we're allowing a user to have input, and anytime we do that, again, we open up ourselves up to these type of vulnerabilities. Okay, so it's not that user data can be trusted. It's just we have to guard against the behavior that we want to see, and not just open up ourselves completely to just running arbitrary code. Okay, so the code that the interpreter processes is a mix of instructions written by the programmer and then the data supplied by the user, right? That's kind of how our programs work, right? It's some of it it's static, but then also some of it is dynamic, and that's a good thing, right? We want dynamic websites because we do want to create those tailored experiences that everybody likes. We kind of want to have be able to create websites that can be can take in user input, and based on that user input, spit out different outputs. But again, so our websites are a mix of these inputs that are static and then these inputs that are dynamic. Okay, so we just have to kind of deal with that. Now, when the attacker supplies input that breaks out of the data context, that's kind of what gets us what can get us in trouble. Okay, and that's usually how these attacks will happen, right? They'll try to break out of the context itself, and like you saw, they have to for this example, in this attack, what we did is we terminated a process. So once we terminate that process, again, we're kind of going outside the scope, and then we're starting a new command, right? So we're terminating one command and then starting a new one, and that allows us to end the execution of one thing and then continue the execution of the next thing, right? So that's kind of how that attack is run. So again, the attacker input gets interpreted as program instructions, right? So because we're writing directly to the server now, right? So this is directly on the shell or the terminal, and at this point, anything that that attacker can do, if it's not sanitized correctly, then it will run. Okay, it will run on your terminal. It's just a server. It's like being, again, at that point, it's complete access, right? And this is normal. Like, sometimes we do expect this behavior. If you're tunneling over SSH, then that's exactly what the behavior that you expect. But it's only when we give access to the user input, and then we're not getting the behavior that we expect. These are the attacks that we can open up ourselves to if we don't sanitize the code correctly. So command injections. The goal of these attacks usually are just to execute arbitrary commands on the host operating system via vulnerable application. So again, this could be in the form of a form. This could be, we've seen it through XSS attacks. But that's kind of the goal, okay? So the command injection attacks are possible when an application passes unsafe user supplied data. So again, through forms, cookies, HTTP headers, anything, to the system shell, okay? And this could be even stored XSS, right? So if it's stored at some point and then at some other point, it's going to get queried back, but it's going to be processed first and foremost by the server, then given to the client. Then at that point, when it's actually being rendered and parsed by the server, at that point it can become vulnerable, right? Okay, so command injections. That's kind of the what we just went over, right? This is the attack, and this is kind of the naive way of doing it, which is just run the whole thing as it comes in. And although we're interpolating here this data, and what we expect is the user to just put one file at a time. That is the expected behavior. We can see that they can obviously write as many commands as they feel like, and end each process and then call another process, and there's really nothing stopping them. So again, the way we stop against those attacks is we're gonna spawn two processes, and in one we're gonna specify the command that we want to run, and the other the inputs, right? So now, because we have these two things separately, we're gonna run one on one side and then the other one, and then kind of merge them. But we're not gonna merge them, like, we're not gonna run it all at once. We're gonna merge them, okay? Instead of running it all kind of like in successions. So that's kind of the defense against that. Okay, so SQL. Let's talk a little bit more about SQL injections. Pretty much, this is we're gonna write a query like this. Okay, again, it's pretty similar to what we just did. So what we're gonna do is we're gonna rewrite our bank application that we've been working on. We're gonna query it, okay? But now we're gonna be querying from a real database, and we're gonna be using SQLite instead of the object databases that we've been using. So I can showcase some of the attacks and how they can be performed, and again, how to guard against some of these vulnerabilities. So let's say we have this type of code written in our server. Select all from the users table where username is username, right? That's kind of the template that we're gonna go with, and then we're going to kind of show all the attacks against this template. How this one single line of SQL can become a vulnerability and a vector space for attacks, okay? And then we're gonna parse the results, and then we're gonna return the results, okay? Now let's go over a few examples, and then we're gonna see it live, right? So this is the template that we're gonna be using. So let's say the user just inputs something regular, right? In the bank application, if you remember, let me go back to it. So now that we're in the bank application, again, we expect the user in this form just to input user and then their password, right? That's kind of the expected behavior. So they can just put in John, and then again, we can see that this is working. Let's just log in into Alice's account for a minute, and then we're gonna submit this. So everything is working as before, right? So we can log in, we can log out, but the difference being is now we've changed our login endpoint, so that in order instead of getting the username from this object that we created here, we actually created an SQL database. Okay, so now we're actually going to be querying a real database. Okay, and then we're gonna see that the attacks that can happen once we have stored data on this database, right? So okay, let's go back. So now again, the expected input is just their username, right? And then from that username, we're just gonna say, hey, select from the users table that we just created the username that matches John, right? And then the database will return to us that user. All right. Now let's look at some of the things that we become vulnerable to. And again, this is going to sound very similar to XSS, but now remember, this is kind of more a stored approach, and these things can kind of be executed in real time as well. Okay, so now what happens if the user doesn't just put in John, but they put in John and then the double quote? Okay, so what's gonna happen is that this is one way to end an execute command, right? So this is one way that that the attacker can end the process and then run extra commands after that double quote. So right, because they're kind of so at this point, if you remember, we're in this template. This is the first double quote. So then our code is gonna run here, and then they're going to early terminate the process, and then they can run kind of anything after this. Okay, so that's kind of the vulnerability right there, right? So if we're just kind of have this template, it opens us up to a double quote ending the process early and then running multiple attacks, multiple commands at the same time, and then that's an attack vector that we have to guard against. So let's say again, same template, right? But now they don't just put in username John, they put John double quote and then I'll double dash. So in SQL, this is a comment, right? So what we're gonna say is, anything after this, we kind of don't want to look at it. Okay, so again, this is the way that we tell in SQL, the way we write comments is this, and we kind of saw some of this stuff in the XSS videos. Okay, so the resulting query is going to be something along these lines: select from the users table where username equals John double quote and then double dash. Okay, and then the double dash kind of opens us up to multiple processes being run at the same time. So then let's look at a real attack vector that can happen. So again, same template, right? But now what are we doing? So imagine this is the input that the user puts in. The username is John. Okay, early termination. So we see an early termination here. And then in SQL, they write or. So if you don't find anything with the name John, then find something where it equals 1 equals 1. So it's essentially like writing John or true. Right, so of course it's either going to find John if that exists or not. It doesn't really matter because the next command it's or true. So it's like running a while true loop on the client side, right? So if we write on JavaScript a while loop that's just a true loop, then someone can DDoS your server, right? Because then that never terminates. This is kind of the same thing but in SQL, right? So it's going to say run. Try to find a user called John, and if you don't find it, then see if anything is true, and then of course we're gonna pass it the value true, which is does 1 equal 1, and of course that will always equal true. So then that will pass, and then we're gonna say this is an SQL comment, so that way we don't have any other issues with terminating the process early, and then the resulting query from that from this input will be the following: select from the user's name anything that's John or something that equals true, and of course we passed that input ourselves, so of course it's going to equal true. Okay, and then that way we can see here that they don't even have to actually include the name. They can just put early termination or true, and then the comments, and of course 1 is always equal to 1, so that's always true, so that will pass, and then then they have kind of access to the database at that point as well. Okay. And then let's see here if there's another one. So yeah, we'll go over this one, but let's try to see how this attack works. So let me come over here and let's try a few things. So first, let's try to just log in as so remember we have to type Alice, and again, if we input a wrong password, Okay, we're gonna get a fail. So everything is working as expected. Okay, so now let's see what happens if we type in Bob early termination and then double dash. Okay, so let's see here, and then I'm not gonna type in any password. Okay, so we're just gonna submit this, and there you go. Right now we are inside of Bob's account, and we can kind of see, kind of their whole account. Right, so at this point they can do a transfer, they can do whatever they want, but essentially they're inside. Right, so at this point you're kind of screwed. So there you go. That's one attack, and that's what we were looking at before, which is again, we wrote the username, right? Then we terminated because of the way that that this query it's written. So it's written pretty naively, and so I'm saying, hey, select from the users table where username is username. So whatever that username is, right, that they put in this form, that's what I wanted to match. And password equals whatever the password is, right? But we're never gonna get to this part of it, right? Because I'm gonna terminate it early in the attack, right? I did an early termination, and then I did a double dash. So I'm saying, hey, just ignore the rest, right? And then that's kind of what I'm the query that's gonna be executed on the database itself. It's gonna say, hey, just find me something that's called Bob, right? And then this rest of the query is not gonna run. So even though it's written on the server, because of the way that the user input was written, then that's never going to run. So it doesn't matter that it's there on the server, and that's kind of what this attack is showcasing. Okay. Now let's write the OR attack. Okay, so now we saw that we included Bob. So that's great. That's great if the attacker knows the actual username. But what if they don't? Okay, can they actually get into any account? Well, this attack will show that they can. Okay, so now we're showing, you know what? Match whatever, which is really nothing. Okay, so match no username or one, right? So we don't even have to know the username. Let's see if we can get in into the database at this point. Well, there you go. Now we're in Alice's account. So what it's going to do actually, so because of the way this query is written, so when we do db.get, the get command on SQL returns kind of the first user. So again, that's just kind of the draw of the luck, essentially. But at this point, it's just going to return the first user. But still, we're able to get into a user's account without knowing even a username, right? That's pretty scary. But again, this is what happens if we don't sanitize our code correctly. Let's also, so let's see that, let's see if we can do something a little bit more mischievous here. So now we're not going to input any username because we really don't know anyone in this database. But we do know what we're interested in, right? So what are we interested in? Hey, let's see if in this database, try to find me anyone, right? So first and foremost, since we know it's going to ask for a username, we're saying find a username or, right? Or, I mean, we're not even going to input anything. We're going to do an early termination or an account that has a balance over, a certain number, okay? At this point, what we want to do is we want to enter an account that has a large balance, right? So large balance. So let's go ahead and submit that. And all of a sudden, we are inside of an account with that has millions of dollars, and the attacker at this point can just start doing a transfer, and you're pretty much screwed, right? So this server at this point is kind of screwed, and the attacker has owned it. Okay, so again, that's kind of running arbitrary SQL commands on the server. But here's another thing. So let's try another attack here. So we're going to do an early termination, okay? But then we're going to write to the actual database. So imagine this. So imagine now we're going to update the users table, okay? Update the users table and set the password to root where the username equals Bob, right? So imagine if first and foremost we're going to find out, right? So imagine if we run the previous command first, and then we find out that that account's holder was named Charlie. Okay, let's just figure that out. And then we're going to say, hey, we're that account because we already know that, right? So the attacker was able to get in. They were able to see that they got another piece of data. Now, with that next piece of data, what they're going to do is they're going to update, because now that they know that this server is vulnerable, then they're going to update the server, right? Because now they know they own the server. But imagine if the user has this, so imagine if the server has another vulnerability. So which is the execute vulnerability that I showed you for. And again, there's no sanitization on it. So they're pretty much going to, let's say they have an audit log. So like they have some audit server where pretty much they're auditing all their SQL commands. So sometimes we do this just to figure out what are the functions that are running that are taking the longest. If you have a lot of things, like especially like with machine learning and things like that, you want to optimize kind of those functions, right? So sometimes you just have an audit server, and what that audit server does, it's just kind of times when a process starts and kind of when it finishes, right? And then that way you can kind of see, hey, what's taking the longest, and once you know that, then you can optimize it in any way that you see fit, okay, or whatever. But it's just a way to see kind of either you need a new architecture or to optimize it, the function itself, or any of those things. So this is actually quite normal, just to have an audit server, especially for bigger systems, right? So imagine that that this command here, and again, what we're gonna say is, hey, insert into the logs database the values for login attempt. So anytime someone tries to log in, we want to have that being logged into the server that we're kind of like having as a as an audit server. Okay, and I'm gonna go ahead and submit this. Okay, so we got an error, right? So we're not able to submit it. But let's see what ran on the server side. And on the server side, although we got a fail, right? So on the client side, and maybe the attacker knows this. So like the attacker's not necessarily interested in getting in at this point, but they're interested in updating a record in one of the databases. Okay, so like I'm just trying to show you kind of what are the some of the vulnerabilities, and then how to defend against these attacks. Okay, so that's the vulnerability. The vulnerability in this case is that because of the way that the execution function is written over here, we kind of have given the attacker arbitrary access to our server. Okay, now they can, again, just because we have access to one of the databases, we can see that through there we gain access to the other database. Okay, and then although we got a fail on the client side, let's go back now. Okay, and let's try to log in. Okay, now this time it's that other user that we just changed our password, and let's log in with the password that we just changed it into, and let's see if we can log in. All right, so now I'm just going to try to log in into this account with the new password that we just created, right? We just updated that table, so let's see if we can get in. And there you go, just like that, we were able to update that table. And again, remember the first command we ran got us access to the account holder's name, and then once we had the account holder's name, we were able to change the table to whatever password we wanted, and at that point we were just able to get in, right? So that's again pretty vulnerable. So that's those are SQL injection attacks. And then in the next lecture, I'm going to show you the defenses against this, how to sanitize them, and how to protect yourself from these things. Because again, although it would suck for sure, especially if you have a bank application that someone can do this, but again, this can happen in any other type of account. And because again, as more of our identities are online, then when someone has access to one of our accounts, it could potentially open us up to them having access to many other accounts. Okay, and that's why, again, you want to use maybe a password manager. That's probably a great defense, because then the user won't be able to so easy get into, if they get into one account and maybe that account is vulnerable, then they won't be able to get into every other account, right? So, and a password manager allows you to create really protective passwords without you having to remember them all. Okay, but even if you do, but let's say you're the developer, then what I want to show you is I want to show you how to defend yourself against these attacks and defend your users against these attacks. Because many times, again, like this can happen for any number of reasons, and it's not that maybe we have malicious users, but this could even come sometimes as mistakes and things like that. Okay, so we want to make sure that that doesn't happen, because stuff like this can also happen, and this could be a huge it's really hard to recover sometimes this data if you don't have any backups or anything like that. But you can just run this command and then drop the table users completely. So I'm gonna run it on that, and although it failed, let's see over here. So we just dropped that users table. So as you can see, when I open up my my SQL database now, if I try to see how many tables I got, that users table, that completely got dropped, right? So that completely got deleted, and that sometimes can be even worse if you don't have a backup of your table. I'm gonna go ahead and also drop from within the client side the logs table. Let's come over here. Yeah, so I'm gonna drop again the logs table and then just delete it, right? So an attacker can actually let's just submit this, and then I'm gonna go ahead and check over here. So if we come back and we refresh, we see that now we have nothing in our database, right? So like it's been completely wiped out. So again, that sucks. So if we open up ourselves, we can see how like little by little, an attacker can from something very simple, right? Like we started with, from a file viewer, right? They can then just run arbitrary commands. So again, let me just make it vulnerable again, because now we have that defense. But imagine that that it was written in this other manner where just it's not sanitized correctly, and then code is being allowed to run arbitrarily. Then the attacker can essentially get a full picture of of the server, right? That's kind of it, right? And then in here we can probably see that there's a file called db, right? And then all these files, and then they can just start performing the db.file right here, right? So they can definitely see that we have a database. And then after that, we can see all the commands that they were able to run in this database from simple commands like getting into well, I just dropped all the tables, so there's no users. Let me go ahead and remove that, and then let's restart the database. Okay, let's open it back up, and then we should see that in the. So now we got our users back. Okay, so we saw simple attacks from, again, now the first attack, they were able to get access to a first piece of data, which is just kind of our whole directory structure. Okay, and then they're kind of able to just log into arbitrary accounts without really knowing passwords at all. They can run attacks that target special accounts, specific accounts that have a certain balance, all these things, right? Like they can pretty much own our own whole server. So again, one way is, again, you want to have a password manager. You want to have like sufficiently double layered defenses, and I'm going to show you in the next lecture how to guard against these XQL commands on the server side once an attacker can potentially run shell commands or terminal commands. All right, so that's going to be important. So anyway, stick around, and I'll see you in the next lecture.